Hey everyone, welcome to the course! Get ready to dive into the exciting world of the Cypress framework and continuous integration, continuous delivery, or CI/CD principles. Throughout this course, you're going to learn how to write solid tests for your web applications. Yes, solid tests! You'll set up automated testing pipelines and seamlessly integrate Cypress with GitHub Actions. You'll gain practical skills like managing user authentication, handling errors, and fine-tuning your CI processes. All the essentials. Plus, there will be some hands-on coding exercises to really solidify your knowledge. And don't forget, there's a final project waiting for you in the GitHub repository. It's your chance to showcase everything you've learned. So be sure to stick around until the end. Let's get started. Cypress is a modern web testing framework that makes it super easy to write and execute tests for web applications seamlessly. Its design is all about giving developers and testers powerful tools that, minimize the logistical headaches that can come with the testing process. In this video, we're going to dive deep into the introduction of the Cypress framework, exploring its key features, examining what makes it stand out in the testing landscape, and, of course, why you should totally consider it for your projects. So buckle up as we embark on this exciting journey. Now let's implement the installation of Cypress, which is actually a pretty straightforward process. First things first, make sure you have Node.js installed on your machine. Nothing fancy there. The very first command we're going to run in the terminal is npm install cypress-savedev. This nifty command utilizes npm, which is the package manager for Node.js, to fetch the Cypress library and install it as a development dependency in your project. And by using the -savedev flag, we're ensuring that Cypress is safely added to your project's dev dependencies. This is super helpful because it means these tools are only needed during the development phase and not actually in production. Once the installation is complete, we're ready to crack on with opening Cypress for the very first time. To do this, it's easy peasy. Just run the command npx cypress open. This will launch the Cypress test runner, which gives you this really interactive user interface where you can manage your test files, create new tests, and visualize your test runs in real time. With this setup, you'll have everything you need to start writing and executing your tests smoothly within a browser environment. So, let's write a test to verify the login functionality of our application. So, let's jump in. We're starting by using the describe function to lay out what our test suite will cover. Today, it's all about the login page. This setup allows us to bundle related tests together, making it easier to analyze later. Within this suite, we defined an individual test using the it function, stating that it should successfully log in with valid credentials. Now, let's roll up our sleeves and implement the necessary steps to simulate a user's login action, shall we? First up, we call the cy.visit command to navigate to our application's login page. This command is crucial because it opens that specific URL right in the browser. After that, we use cy.get to select the input fields for username and password. Super handy! And we sprinkle in the type command to fill them in with our valid test credentials. Once we've entered all the vital info, we mimic a user clicking the submit button with cy.get followed by click. And here's the moment of truth. We assert that the application navigates to the dashboard using cy.url to ensure that the URL reflects the expected path. Finally, we check for a warm welcome message tailored for the logged-in user. Gotta make sure they feel appreciated. And just like that, we've completed our verification of the login flow. Honestly, it feels great to see it all come together. Now, let's dive into implementing a simulated login failure using Cypress. So, to kick things off, we'll start by setting up a Cypress server and defining a route to intercept our login API call. Picture this. When a post request zooms in on the API login endpoint, we want it to respond with a status of 401. Yep, that's the unauthorized error, along with a message saying invalid credentials. This handy trick lets us mock a scenario where a user types in incorrect login details. Pretty clever, right? Next up, we'll mimic user behavior by filling in those username and password fields with some test data. Then, we'll simulate the submission of the login form by giving that submit button a nice firm click. This action kicks off the login request, which our Cypress route is already set up to respond to with that lovely error we configured earlier. Now, to make sure our application is behaving correctly in this failure scenario, we'll use the cy.wait command. This allows us to hang tight until our mocked API call wraps up. We'll check that the status code we get back matches our expectation of 401. And here's the important part. We'll also assert that the error message is visible on the screen. This confirms that our application effectively manages login errors by, informing the user properly. So, this whole setup doesn't just test the user interface, it ensures that the application logic is responding as intended when faced with login failures. It's such an essential part of building robust applications. Now, let's implement a simple configuration that enables video recording for our Cypress tests. To capture video of your test runs, we need to dive into the Cypress configuration file known as cypress.json. Here's the magic. By adding the property video true, we tell Cypress, hey, record those videos of our test executions whenever we run them from the command line. This feature is a game changer for debugging because it lets you review the execution flow and see, exactly what went down during the tests when errors pop up. So, whenever a test fails, you'll see the error details in the console, but you'll also have this handy visual reference showcasing the application's behavior right at that moment. Whoa! Being able to watch the entire test run really helps speed up the process of pinpointing issues, making resolutions not just faster, but way more efficient. Once this configuration is set up, you'll gain enhanced visibility into your testing activities, super essential for effective collaboration among team members and stakeholders. Now, let's dive into how we can implement Cypress tests within a continuous integration or CI environment using GitHub Actions. So the first thing you'll notice is that we need a YAML configuration, and it starts by specifying the workflow name. In this case, we're calling it CI. Next up, we set up our triggers for this workflow with the ON key, which tells the CI process to run whenever there's a push event or a pull request created. This means every time a developer updates the repo, boom, the tests automatically kick off, ensuring everything works as intended. Now, let's talk about the jobs. We kick off with a job named Cypress, and this runs on the latest version of Ubuntu to make sure our environment stays compatible with our tests. Each job comes with several steps, starting with checking out the code from the repository, which we do using the actions/checkout action. This step is essential. Gotta get that code base ready for testing. After we've checked out the code, we move on to install our dependencies with the npm install command. Almost done. Finally, we tell the CI to run the Cypress tests by using the npx cypress run command. This command launches the tests we've written, setting them in motion within the CI/CD pipeline. And just like that, our testing process is automated, which means, hello, more efficiency and a whole lot less risk of bugs sneaking into our projects. Wrapping up, it's clear that Cypress is a robust, powerful framework specifically designed for testing modern web applications with ease. Its accessibility, real-time execution, and powerful features make it an invaluable tool in the software development lifecycle. Whether you're looking to improve the reliability of your web applications, integrate testing into your CI/CD pipeline, or simply streamline the testing process, Cypress delivers a compelling solution that you shouldn't overlook. So go ahead, give Cypress a try, and transform the way you approach web testing. Thank you for joining this session on the Introduction to the Cypress Framework. Happy testing and coding! Now let's dive into implementing a CI pipeline using GitHub Actions. We'll kick things off by defining a workflow name and specifying that it should trigger on any push to the main branch. This ensures that every change we make gets automatically tested. Next up, we'll create a job named Build. It runs on the latest version of Ubuntu, giving us a standard environment for our scripts. The first step in this job is to check out the code from the repository. This allows GitHub Actions to grab the latest version of our code base. After that, we set up Node.js version 14. This is crucial for running our application along with its dependencies. Once Node.js is all set, we install every dependency listed in the package.json file, so our project has everything it needs to run smoothly. Finally, we execute our tests using the npm test command. This step is super important because it maintains code quality by making sure all tests pass after each change. It gives developers an instant heads up about any integration issues. This continuous feedback loop is what really supports a robust development process. Now let's dive into how we can implement continuous delivery using GitHub Actions in our CI/CD pipeline. We'll start with this YAML configuration file that defines a workflow triggering on pushes to the main branch. This ensures that every time you make an update, an automated process kicks into gear. So, first things first, the workflow checks out the latest code from your repository. This step is crucial for grabbing the current state of your application. Next up, we set up the Node.js environment, specifying version 14. This is super important for keeping everything compatible with our app's dependencies. All right, once that's done, we run an npm command to install all the necessary packages. This preps our project for testing. Now, once those dependencies are all in place, the pipeline executes our tests to ensure that our code changes don't introduce any bugs. This is essential for maintaining the stability of our application. If all tests pass successfully, which fingers crossed they do, the next step is deploying the application to a staging environment. And we do that using the command npm run deploy staging. This command is expected to include the deployment logic we need to push our latest build. And as we go through this deployment process, we keep sensitive data secure by utilizing GitHub secrets for any tokens required. This keeps everything safe as we ensure our application is ready for immediate testing in an environment that mirrors production. Now, let's implement a simple integration test using Cypress to ensure that our user authentication functions correctly. So, in this exciting step, we're going to start by grouping our related test cases under a description block labeled User Authentication. This gives us a nice and tidy framework for our tests, super important when you're juggling multiple scenarios. Next up, we define a test case with the it function, which tells us exactly what behavior we're aiming to verify. Can a user log in with valid credentials? All right, let's kick things off by programmatically navigating to the login page of our application using cy.visit. It's like simulating a user actually accessing our app. Following that, we'll use the cy.get command to locate the username and password input fields by their names. Easy peasy. Then we input some valid test credentials. Now comes the fun part. We're going to click that submit button using cy.get and .click. Once we do that, we check if the user is redirected to the dashboard by verifying that the URL contains /dashboard. And just to be doubly sure, we use cy.contains to assert that a lovely welcome message pops up, proving that the login was a triumph. This structure not only confirms that everything is functioning as it should, but it also lays down a solid foundation for our CI pipeline, ensuring that our core features remain operational with every code change. So, once your CI/CD pipeline is up and running, it's crucial to set up some monitoring tools. These tools will help you track your application's performance after deployment. Think about tracking error rates, response times, and user activity, right? Tools like Sentry for error reporting or Google Analytics for user activity can be super helpful here. They really allow you to analyze the impact of the changes you deploy. Now, let's talk about something really important, building a culture of accountability within your team. Everyone on the development team should feel totally responsible for the quality of the code and the reliability of that CI/CD pipeline. Fostering an environment where developers are motivated to write robust code and, actively fix issues, this will seriously enhance your CI/CD processes. Now let's see how we can implement a security scan in our CI/CD pipeline to really enhance the security of our application. The code snippet involves a single step where we run a security audit on the project's dependencies. And here's the cool part. By using the command npm audit, we can check for known vulnerabilities that could affect our application. This is super crucial because as the software landscape is always evolving, the libraries and frameworks we depend on can develop vulnerabilities that might be exploited if we just let them slide. Incorporating this step within our CI/CD pipeline means that every time we push code changes, the pipeline will automatically perform this audit. This helps raise awareness of security issues early on in the development lifecycle, allowing developers to proactively tackle them before they make it out to production. By automating these security checks, we really instill security practices right from the get-go, ensuring that our application is protected against those pesky potential threats. Seriously, this proactive approach is essential for maintaining a robust and secure software development process. With an encouraging tone, understanding and implementing CI/CD principles can truly transform your development workflow, allowing for faster releases and higher product quality. By embracing continuous integration, you enable your team to integrate code continuously, which helps avoid those pesky conflicts and keeps your code stable. And with continuous delivery, you create a smooth pathway for deploying changes, which reduces the risks linked to release schedules and boosts team productivity. Who wouldn't want that? By strengthening these principles, like maintaining reliable builds, automating tests and deployments, keeping an eye on performance, fostering accountability, and integrating security, you set your team up for success. As software development continues to evolve, CI/CD remains a vital approach to building and delivering software efficiently and effectively. Thank you for joining this discussion on CI/CD principles. With these foundations in place, you're now better equipped to implement these practices within your team and harness their full potential in your software development journey. Happy coding! Now that our project is established on our local machine, the next step involves installing the necessary dependencies to ensure everything operates seamlessly. We will proceed with the command that facilitates the installation of these essential packages. This command references the package.json file, which contains a list of all the dependencies required for our project. By executing this command, we initiate the process of incorporating these dependencies into the Node modules directory. This step is vital, as lacking the appropriate packages could lead to frustrating missing module errors when running tests or building processes. Additionally, ensuring that your environment is properly configured with all required dependencies lays a stable groundwork for executing tests in the future. Testing frameworks like Cypress rely on specific libraries to operate effectively, and the absence of these can create significant obstacles that hinder progress. Once we successfully install the dependencies, we can proceed to configure Cypress for our testing framework, enabling us to streamline the testing process within our CI/CD pipeline. A well-established development environment is crucial for seamless integration and delivery within the CI/CD workflow. To begin, we will be writing the command necessary to install Cypress in our project. So, go to your terminal and enter npm install cypress-save dev. This command will add Cypress as a development dependency, enabling you to utilize this fantastic testing framework in your testing suite. Setting up our testing environment correctly is a vital step. Next, let's learn how to open the Cypress test runner. Simply type in npx cypress open. This command starts the Cypress application and sets up a default folder structure, which includes useful folders like fixtures, integration, plugins, and support. Each of these folders serves a specific purpose, with the integration folder being the key area where we will write our test specifications. Now, we will create a simple test in the integration folder to ensure that our application loads correctly. We'll name the file app_spec.js, where we will define our test suite using the describe function. Within this suite, we will include a test using the it function, which will navigate to our application's URL with cy and verify the presence of the welcome message using cy.contains and should.beVisible. This test is crucial as it is an essential part of our integration strategy, ensuring that the application behaves correctly when it loads. Now let's implement a super handy GitHub Actions workflow to set up a continuous integration pipeline for your application. First up, we define the name of the workflow as CI/CD pipeline and set it to trigger on every push event to the main branch. This little tweak ensures that our CI process runs automatically whenever we make changes to the primary code base. Next, we're going to create a job named Build, which will run on the latest version of Ubuntu. Under this job, we'll detail a series of steps to keep everything running smoothly. To kick things off, we'll check out the code from the repository using the actions.checkout action. This allows our workflow to access the latest code. Then, we'll set up Node.js, specifying version 14, which is absolutely essential for our environment, since our application relies on it. Following that, we're going to install all project dependencies by running npm install. This step ensures that all the necessary libraries and tools are available for our tests. Finally, we'll execute our Cypress tests with the npx cypress run command. This final step is crucial as it assesses the application's functionality. If any tests fail, the pipeline halts right there, providing immediate feedback for developers to jump in and fix issues before deployment. Now, let's dive into how we can supercharge our CI/CD pipeline by specifying the exact conditions under which our tests are executed. In this part, we'll be focusing on tweaking the trigger settings, ensuring that our tests only run when relevant files in specific directories are modified. By fine-tuning the on section of our workflow, we can make it listen for pull requests. This way, we really narrow down the scenarios in which our Cypress tests spring into action. So here's the deal. This code will listen for those pull requests and define the paths that our workflow will keep an eye on, specifically honing in on all files within the src and Cypress directories. Now, this means that our CI process will only run tests if changes occur in these critical areas of your project. Think about it. This approach boosts efficiency by preventing those unnecessary test executions for unrelated changes lurking elsewhere in the codebase. Implementing this kind of condition is a game changer, moving us closer to a more responsive and streamlined CI workflow. It empowers developers to zoom in on relevant updates while getting focused feedback on significant modifications. These smart optimizations can really ramp up the speed of your development cycle, ultimately enhancing your team's overall productivity. Now, let's dive into a step that's going to supercharge our CI/CD pipeline with top-notch error handling. To keep our deployment smooth, even when we hit unexpected bumps in the road, we're going to set up a Slack notification that triggers if the deployment fails. So, this will be managed through a conditional step that activates only when a failure occurs in the previous steps of our workflow. We'll use the Slack GitHub action for this integration, and here's the cool part. We'll specify the channel ID where those notifications will land. That channel ID, along with a secure token safely tucked away in GitHub Secrets, lets the action run without exposing any sensitive info. Pretty neat, right? So, if a failure happens during the deployment, the action zips off a message saying, "Deployment failed," right to the designated Slack channel. This instant communication is invaluable because it allows your team to jump on deployment problems quickly, maintaining transparency and keeping the workflow efficient. Integrating this kind of error handling into your CI/CD pipeline is just good practice in modern software development. It really promotes identifying and resolving problems proactively during the deployment process. Today, we dive into the exciting world of web testing automation with a focus on two prominent frameworks, Selenium and Cypress. Understanding the contrasting capabilities of these tools can drastically impact how we approach web application testing. So, let's break it down. Selenium is like your classic tool, a veteran in the automation game, able to work across various browsers and platforms. However, Cypress is a newer player, offering a more modern and streamlined approach that might just make your testing life a whole lot easier. You see, while Selenium requires a bit of setup and configuration, Cypress lets you run tests right in the browser, which means you get real-time feedback. But hold on, it's not just about ease. When it comes to speed, Cypress pulls ahead with faster test execution, thanks to its architecture. So, whether you're looking for flexibility with Selenium or speed with Cypress, knowing their strengths can really make a difference in your testing strategy. Get ready because we're going to unpack these frameworks more, and trust me, you'll want to stay tuned for all the juicy details. So far, we learned about integrating continuous integration and continuous delivery into existing projects, emphasizing their vital role in modern software development. We covered setting up a proper development environment, installing necessary dependencies, configuring the Cypress testing framework, and automating the CI/CD pipeline using GitHub Actions. The lesson highlighted steps for managing builds, running tests, and deploying applications, along with incorporating error handling and notifications for a smooth workflow. Overall, these practices empower teams to enhance software quality and facilitate efficient release processes. Now, let's dive into the fundamental differences between Selenium and Cypress. We're going to examine each framework's features, usability, and optimal use cases. So, grab your notes because this is where it gets really interesting. With Selenium, you've got a robust tool that's been around for quite some time, making it a solid choice for web applications across various browsers. But Cypress? That's like the new kid on the block. It's fast, intuitive, and built specifically for JavaScript frameworks. We'll explore how Selenium handles testing in a more traditional way, and then contrast that with Cypress's groundbreaking approach, which allows for real-time reloading and time travel debugging in your test cases. Plus, you'll see why Cypress is championed for its simplicity and the seamless integration with modern front-end libraries. Buckle up as we break down the features, usability, and some use cases where each shines. You're going to want to stick around for this. Now, let's dive into how we can implement a simple test using Selenium with JavaScript. So first up, we need to import some essential components from the Selenium WebDriver library. Think of these as our toolkit. We're grabbing builder, by, key, and until. These are crucial because they let us interact with the browser, locate elements, send input, and wait for specific conditions. Next, we'll create an asynchronous function. This is where we build our Chrome browser instance using the builder. It's kind of like setting up our testing environment. Think of it as prepping our automation playground. Now, after building the driver, we use the get method to navigate to a specified URL. In our case, we'll use a test website. This step is vital because it sets the stage for all our test actions. Then, we'll locate the search input field by its name attribute using find element. Imagine this, we're simulating a real user typing the term Selenium and then hitting the return key. This interaction mimics authentic user behavior, which is super important for validating the search functionality. And here's the best part. Regardless of whether our test passes or fails, we make sure to close the browser by calling driver.quit. It's essential to free up those system resources, right? So, this succinctly illustrates the basics of using Selenium for web automation testing. All right, here we go. Let's dive into implementing effective waiting for elements in Selenium, shall we? In web automation, it's super important to make sure that the elements we're working with are actually loaded and visible before we try to interact with them. This helps us avoid errors during test execution, So the first line of our code is doing some magic with the driver.wait method paired with the until.elementLocated condition. What it does is pause the test until it finds the element with the specified ID, which in this case is myElement. And guess what? We set a maximum wait time of 5 seconds. Once the element is located, we grab it using driver.findElement and store it in a variable called myElement. This is a key step because it gives us a reference to the element we want to manipulate. Now here comes another interesting part. We apply another driver.wait to wait for myElement to actually become visible on the page, again allowing up to 5 seconds. This two-step waiting process really emphasizes how controlling the execution flow in Selenium is critical. It's like laying down the groundwork for effectively handling those dynamic web elements. By implementing these waits, we boost the reliability of our tests, ensuring they're only running when all the necessary elements are ready for action. Such a smart move, right? Now, let's implement a simple Cypress test that demonstrates how to interact with a web application. First up, we use the describe function to group our test case. This gives us a clear structure for our test suite, and we're calling it myFirstTest. Inside this suite, we define an individual test with the it function, where we describe exactly what this specific test is going to do, namely visiting the kitchen sink demo site. Next, we kick off our test by navigating to the URL http://example.cypress.io using the cy.visit command, which tells Cypress to load the specified web page. Once the page is loaded, it's time to simulate some user interaction. To do this, we use cy.get to select an anchor element, one of those A tags containing the text type. The contains method is super handy here. It allows us to pinpoint elements based on their text content. After we've located that link, we call .click to mimic a user clicking on it. Lastly, to make sure everything works as expected, we assert that the resulting text within an element with the class .result matches you clicked the button using should.have.text.so. This assertion is our way of verifying that our test behaves correctly, aligning perfectly with the behavior we expect after that click action. And just like that, this straightforward and readable syntax showcases Cypress's strength in writing high-quality tests with enhanced clarity. Cypress really shines when it comes to its time travel functionality, and let me tell you, it makes debugging a whole lot easier. So, each command you run in Cypress actually creates a snapshot of your app's state. This means you can easily peek into what happened during your test execution. How cool is that? You just hover over the commands in the command log, and voila! You can see the state of the DOM at every single step. This feature is a total game changer for developers, saving tons of time and frustration compared to the old school method of, littering your code with console.log statements. Trust me, that's not just more convenient, it's way more efficient too. Now, let's dive into something a bit tricky, handling iframe interactions within Cypress. Trust me, it can be quite the challenge compared to other frameworks like Selenium. So, to kick things off, we start by selecting the iframe element. We're using a CSS selector here, #iframe. Got that? Once we've grabbed that element, we can tap into the its method to access the content document property of the iframe. This lets us explore the whole iframe's DOM. After we've got the content document, we go ahead and access its body, which means we can interact with elements inside the iframe just like they're part of our main page. Now, here's the kicker. We utilize Cypress's wrap function, which rewraps the body so Cypress can seamlessly interact with it as if it were a standard element. This step is crucial because it bridges that interaction gap between Cypress and the iframe's elements. Finally, we whip out the find command to locate a specific element, let's say an input field with the ID #input, and we assert that it's visible. This technique really shows how Cypress handles iframe's content, even though it's a bit more complex than direct DOM interactions. It's a perfect example of Cypress's adaptability, despite the challenges it poses. In conclusion, the choice between Selenium and Cypress really hinges on a couple of key factors, like your project needs, your team's specialties, and of course, the tech stack you're working with. So, if you're looking for something robust, Selenium is still a fantastic option. I mean, it offers flexibility, solid cross-browser support, and can play nice with several programming languages. But if you're after a more modern approach that emphasizes speed and simplicity, particularly for those JavaScript-heavy projects, well, Cypress might just be your best bet. Now, throughout your testing journey, whether you ultimately choose Selenium or Cypress, keep this in mind. Both tools can be your strong allies in delivering top-notch software quality. With a good grasp of their features, trade-offs, and ideal use cases, you'll be set to make informed decisions that can truly elevate your development and testing processes. This wraps up our introductory overview of Cypress and Selenium. Happy testing, everyone! And remember, the right tools can make all the difference in delivering high-quality applications. So get out there and put these frameworks to good use. It's gonna be a game changer.
Now let's see how we can implement a simple test case using Cypress to ensure our web application loads correctly. The code structure begins with a describe block, which serves as a container for our test suite, helping us organize related tests logically. Inside this block, we define a specific test case using the it function, which describes the behavior we are going to test, in this case, checking whether the home page loads successfully. We start by using visit to navigate to the specified URL, in this instance, http://example.com. This command tells Cypress to open the page in the browser for testing. Following that, we use title, should include example domain to assert that the page title contains the expected text, example domain. This assertion is crucial, as it verifies that the correct page has loaded and helps ensure the user's navigation experience aligns with expectations. By utilizing Cypress's built-in functionalities, like the time travel feature, this test not only runs efficiently in modern browsers, but also allows developers to see the precise steps executed during the test, further enhancing our debugging capabilities and overall testing strategy. Now let's take a look at how we can implement a simple test case using Selenium WebDriver to verify a web page title in Internet Explorer. The code begins by importing the necessary components from the Selenium library, specifically the builder, and by classes which help in configuring and locating web elements. In the main function, we initialize a new browser instance by using the builder class, specifically targeting Internet Explorer. After setting up the driver, the function navigates to the target website, in this case, http://example.com. Once the page loads, we retrieve the title of the web page through the getTitle method. This is where the test's core logic takes place. We check whether the title contains the expected text, example domain. If it does, a success message is logged to the console. Otherwise, a failure message is shown. Finally, it's essential to ensure that the browser session is terminated using driver quit, which is called within a finally block. This guarantees that resources are cleaned up properly regardless of whether the test passes or fails. This structure emphasizes the importance of clean test management in a multi-browser testing scenario. Now let's take a look at how we can write a Cypress test to interact with a user profile component in a single-page application. In this example, we begin by defining a test suite using the describe function, which groups together related tests. Within this suite, we use an it function to specify our test case, focusing on verifying that the user profile is displayed correctly. To initiate the test, we call visit with the URL of the user profile page. This function instructs Cypress to navigate to that specific page in the browser, acting as a real user would. Once the page is loaded, we leverage Cypress's powerful chaining syntax to interact with DOM elements efficiently. First, we check that the user's avatar is visible on the page using get avatar should be visible. This ensures that the avatar element is not only present in the DOM, but also displayed to the user. Next, we verify the presence of the username by asserting that the element with the class username contains the expected text John Doe using get username should contain John Doe. This assertion confirms that the application is correctly rendering the user's information, showcasing Cypress's ability to seamlessly mimic user interactions and validate the UI effectively. Now let's implement a more flexible approach to testing across multiple browsers using Selenium. First, we begin by importing the necessary components from the Selenium WebDriver library, specifically the builder and buy modules. This will provide us with the tools needed to initialize web browsers and locate elements on the page. Next, we define an asynchronous function called runTestOnBrowser, which accepts a browser name as a parameter. Inside this function, we create a new instance of the browser specified, allowing the test to run in the context of that browser. This encapsulation is key to enabling multi-browser tests since it abstracts the browser initialization process. After loading the desired URL, we have a placeholder comment where we can insert our test logic, meaning you can customize the checks based on your application's needs. Finally, the driver quit method ensures that the browser closes cleanly after the test execution, preventing resource leaks. To execute tests across various browsers seamlessly, we utilize an array listing the browser names, Chrome, Firefox, and Internet Explorer. With a simple loop, we call the runTestOnBrowser function for each browser, allowing us to run the same test setup in different environments, thereby demonstrating Selenium's versatility and extensive compatibility with different browser types. Next, let's explore the practical implications of these differences for developers and QA teams. When individuals choose a testing framework, they'll need to evaluate their users' actual environments and ensure their tests reflect real-world usage. For example, if your application's target audience primarily uses Google Chrome, then Cypress may be more appealing due to its speed and developer-friendly features. You can afford to invest the time to integrate Cypress into your development process since it accurately mimics the user experience on the primary browser. Conversely, should your analytics reveal a significant portion of users still employing Internet Explorer or older versions of Safari, choosing Selenium for its backward compatibility becomes essential. It maintains the flexibility to test in varying conditions with lesser current requirements for modern systems. In conclusion, the choice between Cypress and Selenium boils down to your project needs and your user base. If the engagement metrics suggest that your clients or users predominantly utilize modern browsers, embracing Cypress will not only enhance your testing experience, but also lead to a more robust application as a result of its immediate feedback loop. However, for teams with broader browser compatibility demands, or those that have to deal with legacy browsers, opting for Selenium is the way to go. As we wrap up this extensive discussion, always keep in mind the practical needs of your testing routines and the browsers your application must support. The framework you select should effortlessly align with your testing goals while fostering an efficient development workflow. Until next time, happy. Now let's take a look at how we can implement a test to ensure the appearance of the login button matches our expectations. In this test, we begin by describing a test suite titled Login Button Appearance using Cypress's describe function, which organizes our tests into manageable sections. Within this suite, we define an individual test using the it function, stating that it should confirm the button style. We start by visiting the login page of our application with visit http://example.com/login. This command instructs Cypress to load the specified URL, simulating a user navigating to the login page. Next, we focus on the login button using get login button, which retrieves the button element by its class name. The subsequent assertion checks that the button's background color matches the expected value, in this case, RGB 0, 123, 255. This verification step is crucial, as it ensures consistency in styling across different web browsers. By executing this test, we can confidently identify any discrepancies in the button's appearance, promoting a consistent user experience regardless of the browser being used. Now let's take a look at a practical example of testing responsiveness for a navigation menu using Cypress. In this test, we begin by defining a test suite called Responsive Navigation Menu, where our first test case is geared towards verifying the behavior of a menu on mobile screens. To simulate a mobile browsing experience, we set the viewport to replicate an iPhone 6. This functionality allows us to create conditions that mimic how users would actually interact with the application on their devices. After establishing the viewport, we direct Cypress to visit a specific URL where our application is hosted. Once the page loads, we employ a selector to target the navigation menu, specifically looking for a CSS class indicating that the menu should be collapsed on smaller screens. By asserting that the menu contains the collapsed class, we ensure that the application behaves as expected in a mobile environment. This approach effectively highlights how responsive design principles translate into real-world functionality, ensuring that users have a seamless experience regardless of the screen size they are using. Now let's implement a test to simulate slower network conditions and verify that our application can handle them effectively. In this code, we start by describing a test suite named Slow Network Conditions, which groups related tests together for organization. Next, we define a specific test that checks if the dashboard successfully loads after a delay. To create the slower network conditions, we use intercept to intercept a GET request to the dashboard endpoint, introducing a delay of 2000 milliseconds, 2 seconds before the response is sent back. This mimics real-world scenarios where users may experience lag due to slower internet speeds. We give this intercepted request an alias, getDashboard, which allows us to reference it easily later in the test. Following the interception, we navigate to the dashboard by using visit, pointing to the URL where our application is hosted. After the visit command, we employ wait to pause the test until our aliased request getDashboard completes. Finally, we assert that the dashboard element becomes visible after the delay using get and should check its visibility. This test ensures that our application remains functional and user-friendly even under less than ideal network conditions, enhancing the overall user experience. Next, we will write a test that verifies secure API access by checking whether unauthorized users are denied access to protected resources. In this example, we set up a test suite using the describe function, which allows us to group related tests under the title Secure API Access. Inside this test suite, we define a single test case using the it function titled should deny access without authentication. Here we utilize Cypress's powerful request method to make an HTTP request to a secure endpoint. The request is aimed at accessing a specific API URL that requires authentication. However, to ensure that our test simulates an unauthorized user, we set fail on status code, false, which allows Cypress to proceed even when the server responds with an error status rather than failing the test immediately on a 4xx status code. After making the request, we use a callback function with then to handle the response. By asserting that the response's status is equal to 401, we confirm that our application correctly denies access to users who aren't authenticated. This reinforces our application's security measures and demonstrates the importance of defensive testing in safeguarding against potential unauthorized access. Keeping up with ever-evolving technology and frameworks introduces yet another challenge: the pace of updates. Libraries, tools, and frameworks are frequently updated to include new features and improve performance. While this evolution is beneficial, it can lead to instability in your existing tests. A feature that worked flawlessly in one version might suddenly break after an update. It's crucial to maintain awareness of the tools and libraries used in our projects. Regularly updating your dependencies and proactively testing after updates are sound practices that can help minimize disruptions. Cypress's API provides great documentation, making it easier to adapt your tests when updates arise. Reflecting on our earlier example, when Cypress updates its API, you'll want to ensure all your tests align with the latest methodologies. Running an audit of your existing tests can help find deprecated commands or changes in syntax that you need to address promptly. Last but certainly not least, we come to the importance of effective collaboration among teams. Modern web applications are typically built by cross-functional teams, encompassing developers, testers, designers, and product owners. Effective communication and collaboration between these roles are vital to address challenges efficiently. Cypress can enhance this collaboration by providing features such as Test Runner that visually displays real-time test execution and results. By using Test Runner, team members can collectively review test outputs, facilitating discussions around any failures or inconsistencies. Sharing feedback easily among team members can help everybody stay on the same page when addressing issues. Regular meetings or check-ins can establish a culture of continual improvement, ensuring that all members contribute to optimizing the testing process and collectively tackling challenges as they arise. In conclusion, modern web testing presents a multitude of challenges stemming from diverse browser environments, responsiveness across devices, performance under different network conditions, security concerns, rapid technology updates, and the need for effective collaboration. However, utilizing frameworks like Cypress can significantly alleviate these challenges through effective APIs, user-friendly features, and vibrant community support. By strategically addressing these concerns, you can enhance your testing processes and ultimately deliver high-quality web applications that provide excellent user experiences. So as we take our leave today, remember that while challenges may seem daunting, they can be met with the right strategies, tools, and teamwork. Just like any good adventure, a few obstacles may arise along the way, but with a little creativity, we can navigate our way to testing success. Now let's take a look at how we can write our first test using Cypress. In this example, we define a test suite using describe, which groups related tests together. Within this suite, we have a single test case defined by the it function, describing the action of visiting a web page designed for demonstration. The test begins by calling visit, which navigates to the specified URL. This function is fundamental as it initiates the testing process by loading the targeted web page. Following that, we use contains to find an element on the page that contains the text type and simulate a user interaction by invoking the click method. This action mimics a user clicking on a link, showcasing Cypress's capability to seamlessly integrate user behavior into the testing flow. Next, we assert the outcome of our actions using URL should, which ensures that the current URL includes the expected string commands actions. This assertion confirms that the application behaves as intended after the click event, reinforcing the reliability and accuracy of the test. Through this straightforward example, you can observe how Cypress's command chaining provides a clear and effective way to create comprehensive tests that align closely with user interactions. Now let's see how we can implement a test that simulates logging into an application using Cypress. In this test, we initiate by visiting the login page through the visit command, which loads the specified URL in the browser. Next, we fill out the login form by targeting the username and password fields using CSS selectors with the get function. This function allows us to select specific elements in the DOM, making it straightforward to interact with the inputs. We then utilize the type command to input the credentials directly into the respective fields, simulating user actions. After that, we submit the form with get form submit, which mimics the action of clicking the submit button. This is crucial for executing the login process as intended. Finally, to verify that the login was successful, we check the current URL using the URL should include dashboard assertion. This ensures that the application redirects to the dashboard page after a successful login. Overall, this script effectively demonstrates how Cypress can be used to automate a login process in a web application while keeping the code clean and understandable. Now let's see how we can assert the application's state after a successful login. In this example, we utilize Cypress's built-in assertion capabilities to confirm that a welcome message is visible on the screen once the user logs in. By using the get command, we target the element containing the class welcome message, which is presumed to display the confirmation of a successful login. The assertion method should be visible is then used to verify that this element is present and displayed to the user. This ensures that the login process has been completed successfully and provides a clear indication that the application behaves as intended after the user's action. Properly asserting such conditions not only enhances test reliability, but also minimizes false negatives, making the testing process smoother. By integrating these assertions within your tests, you can build confidence in your application's functionality, ensuring users receive the expected feedback after logging in. This is a crucial step in validating that the user experience is seamless and aligned with the application's requirements. Now let's see how we can implement network request interception in Cypress to enhance our testing capabilities. First, we use the intercept command to listen for a specific HTTP GET request aimed at retrieving user data. In this case, we are simulating the fetching of user information from the API endpoint /API/users. By specifying a fixture, users, JSON, as the response, we can control the data returned by the backend, which ensures our tests remain fast and isolated without relying on a live server. Next, we navigate to the user's page using visit. This action triggers the network request defined in the previous step. To ensure that our test accurately reflects the state of the application, we employ wait to pause the execution until the request we intercepted, getUsers, has completed. Finally, we assert that the DOM contains the expected information by checking that the user listing elements match our predefined criteria, i.e., checking that there are 5 users loaded in the list. This whole workflow showcases how utilizing intercept streamlines managing asynchronous requests, making our tests more robust and reliable. Now let's take a look at an example of a user registration test using Cypress. This test script encapsulates the functionality required to ensure that a new user can successfully register on the application. The first step in our test is to navigate to the registration page using the visit command, which specifies the URL we want to load. Once on the page, we simulate the user filling out the registration form. We utilize the get command to select input fields by their name attributes, allowing us to type in an email and a secure password using the type function. This interaction closely mimics how a real user would input the data. After entering the information, we call get form submit, triggering the form submission as a user would. Following this, it's vital to verify that the registration process was successful. We do this by checking for the presence of a confirmation message on the page, asserting that it contains the text registration successful using the should command. This end-to-end test effectively ensures that the user registration workflow operates as intended, validating both the interaction and the expected outcome for the user. Moreover, Cypress excels in terms of ease of setup and integration. The installation process is straightforward. Typically, one can bootstrap a Cypress project with a simple terminal command. What makes Cypress even more appealing is its active community and comprehensive documentation, which provide ample resources for developers looking to learn. Transitioning to Cypress from other testing frameworks requires minimal overhead, allowing teams to adopt it rapidly. In conclusion, the Cypress framework is a game changer in the realm of web application testing. Its robust functionality, ease of use, and comprehensive assertion capabilities make it a top choice for developers. By allowing for precise interaction with the application and providing solid mechanisms to assert application states, Cypress empowers teams to deliver higher quality software through effective testing practices. It's time for you to dive into integration and take advantage of these powerful tools. Get ready to enhance your web application testing strategy and ensure that you have a reliable and engaging user interface for your users. In our next lesson, we will explore advanced topics in Cypress, including how to manage complex testing scenarios and utilize additional tools to further improve our testing processes. Until next time, happy. Now let's take a look at how we can simulate an e-commerce user journey using Cypress. In this example, we are defining a test suite called e-commerce user journey, where we focus on the scenario of placing an order. We begin by navigating to the home page of the application with visit /, which sets the starting point for our test. Next, we'll interact with the search input field by using get #search input, type laptop, simulating the action of a user searching for a product. Following the search operation, we click the search button with get #search button, click. Once we have the search results, we simulate selecting the first product from the list using get product list item, first, click. followed by adding this product to the cart by interacting with the Add to Cart button. The flow continues as we navigate to the cart and proceed to checkout using their respective identifiers. This succinct representation effectively mimics real user behavior, allowing for a seamless and realistic end-to-end testing experience that can be extended with additional validation checks or assertions in the future. Next, we will write a custom command to handle user login, which will streamline our tests. This command, created with Cypress Commands Add, encapsulates the repetitive actions involved in logging in, making it reusable across different tests. Within this command, we first navigate to the login page. Following this, we utilize get to target the username and password input fields, where we then use type to input the appropriate credentials. The final step in the command is submitting the form with get form submit, which mimics the action a user would take. Now let's see how we can implement this command within a test suite. In the test case, we invoke our custom login command by calling login with a username and password. This approach not only enhances the readability of our tests, but also reinforces consistency across them. Finally, we confirm the successful login by asserting that the URL includes dashboard, ensuring that the application redirects to the correct page after authentication. This systematic approach simplifies our testing strategy, enabling us to focus on user behaviors rather than repetitive login steps. Now let's implement the following code to validate our auto placement process with meaningful assertions. In this test, we first navigate to the home page and simulate user actions, such as searching for a product and adding it to the cart. Once we proceed to checkout, the code checks that a confirmation message appears on the screen. Using Cypress's Chai assertion library, we assert that the confirmation message is visible and contains the expected text. This is crucial, as it verifies that the user receives appropriate feedback upon successful auto placement. By ensuring that the confirmation message is not just displayed, but also contains the correct information, we enhance the overall quality of our tests. Incorporating assertions like this empowers you to easily catch discrepancies and defects, as they confirm that the application behaves as intended. Meaningful assertions serve a dual purpose. They not only validate outcomes, but also enrich your test by reinforcing user experience expectations. Thus, you're able to maintain a reliable testing process that aligns with user needs in your e-commerce application. Next, we'll implement a user profile test that effectively utilizes fixtures in Cypress. In this test, we begin by defining a before each hook to set up our test environment. This section will load user data from a fixture file named user.json, which contains the username and password required for login. The intercept command is then employed to mock the login API request, returning a simulated response with a token. Now let's see how we can utilize this setup in our test case. The main test, titled "Should display user profile after login," involves using a previously defined custom command for logging in. We pass the username and password loaded from our fixture data into this command, ensuring that our tests remain clean and focused on user interactions. After waiting for the login request to complete, the test directs the user to the profile page. Finally, we check to make sure the displayed username corresponds with the one in our fixture, confirming that the login was successful and the user data is correctly rendered. This approach not only enhances test reliability by avoiding real API calls, but also emphasizes the importance of fixtures in creating robust Cypress tests. Now let's take a look at how we can incorporate debugging into our test using Cypress. In the example, we target an input field for the username using the get command, enabling us to interact with it in our test. We then use the type method to simulate a user typing in the username test user. However, where things get particularly interesting is with the inclusion of the debug command. By adding this, Cypress pauses the execution of the test, which provides an excellent opportunity to interact directly with the browser interface. During this paused state, you can inspect the DOM elements and understand the state of the application at that moment in time, providing invaluable insights when tests might fail unexpectedly. This helps in identifying any issues or discrepancies in your application more efficiently. Finally, the test asserts that the value of the input field matches the expected username using the should assertion. This complete flow not only demonstrates interaction with the application, but also emphasizes how to effectively utilize debugging tools within Cypress to enhance your testing strategy. Now let's implement a configuration file that specifies the base URL for our Cypress tests. This is essential for enabling tests to run across different environments, such as development or production, without changing our test code. we define a JSON object where we set the base URL property to the local development server's address, which allows Cypress to understand where to direct its testing operations. Next, we will explore how to switch between environments easily. To test against a staging environment, we can run Cypress with a command that overrides this default configuration. This prevents the need to modify the base URL in the configuration file for each test run. Instead, we can specify the staging URL through the command line, enabling more flexible testing. This setup allows us to maintain our test's integrity while easily adapting to different operational contexts, ensuring that our application behaves consistently for users across various deployment stages. This technique fosters a robust testing strategy, enhancing our ability to catch environment-specific issues early in the development lifecycle. Now let's implement a continuous integration (CI) workflow for our Cypress tests. The YAML configuration defines the CI process, triggered by pushes to the repository. This initiates a job named test, which runs on the latest version of Ubuntu. The process begins by checking out the code from the repository, ensuring that the CI server has access to the latest version of your application. Next, we set up the Node.js environment using a specified version, in this case, version 14, which is essential for running our Cypress tests. After setting up the environment, we proceed to install the necessary dependencies listed in the project's package, JSON file, which are vital for Cypress to operate correctly. Finally, we execute the Cypress tests using the command to run Cypress in the command line interface. By integrating the CI workflow, we ensure that every time code is pushed, our tests are executed automatically, helping maintain the integrity and functionality of our application. This practice ultimately contributes to a robust development process, catching potential issues early and providing rapid feedback on the code's quality. When using an identity provider, we are essentially delegating the credentials management, authentication, and other authentication-related operations to a third-party product. This process impacts how we assert application states when writing tests in frameworks like Cypress. In this lesson, we will delve into the intricacies of assertion in application states, focusing on how we can ensure that our application behaves as expected during authentication processes and beyond. So far, we learned about effective techniques for writing end-to-end tests using the Cypress framework, emphasizing user perspective, custom commands, and meaningful assertions. We discussed how to simulate user journeys, manage data with fixtures, and utilize Cypress's debugging tools. Also, we explored the importance of testing across different environments and integrating tests into a CI pipeline for enhanced automation and code quality. Today, we will focus on the assertion of application states and how it plays a critical role in verifying the reliability and security of our applications. Now let's explore the code that tests user authentication through an identity provider. First, we define our test suite using describe, which helps organize related test cases. Within this suite, we have a test case encapsulated in an it block describing the functionality we are validating, the redirect to the dashboard, and the display of user information. Next, the code begins by navigating to the login page. It uses the visit command to direct the browser to the specified URL. Following this, we simulate user input by targeting the username and password fields with get combined with the type method to enter credentials. After populating the fields, we submit the form using get form submit. Upon submission, we implement key assertions to verify the expected outcomes. We check if the URL now includes dashboard, confirming that the user has been redirected correctly. Moreover, we assert the visibility of the welcome message that contains the user's name, validating that the application identifies the user post-login. These assertions are essential to ensure that both authentication and user identification functions operate as intended, enhancing our testing framework's reliability. Now let's see how we can implement error handling for invalid login credentials. In this test case, we first describe a new scenario, specifying the intention to check if the application correctly displays an error message when the user enters invalid credentials. We begin by directing Cypress to navigate to the login page using the visit command. Next, we simulate user interaction by inputting an incorrect username and password into their respective fields. After providing these credentials, we submit the login form. This action triggers the application to process the login attempt, which includes validating the credentials entered by the user. Following the submission of the form, we assert that an error message becomes visible on the screen. This is a crucial step, as it verifies that the application responds appropriately to incorrect inputs. By checking the visibility of the error message and ensuring it contains the specified text, we confirm that the application communicates clearly about the failed login attempt. This kind of assertion is not only about verifying functionality, but also about enhancing the overall user experience by providing constructive feedback in response to errors, ensuring users can correct their mistakes effortlessly. Next, we will write the following test case to ensure proper functionality when a user logs out of the application. This code defines a test suite for user logout called user logout. Within this suite, we use a before each hook to log in a test user, utilizing a reusable custom command that simplifies the login process. In the individual test case, we simulate the action of clicking the logout button. This action is critical as it triggers the logout sequence within the application. After the button is clicked, we assert that the URL now includes login, which indicates that the user is redirected to the login page as expected. This redirection is an essential security measure to ensure that users cannot access protected routes post-logout. Furthermore, we validate that the welcome message is no longer present by checking its existence on the page. This assertion reinforces the idea that proper logout functionality not only protects the application, but also provides a seamless user experience by visibly confirming the logout process. Overall, this test case's purpose is to ascertain that the logout feature operates correctly, maintaining application security and proper user notifications. Now let's explore how we can implement tests for user roles within our application. We start by creating a test suite for admin user role tests, which ensures that both admin and regular users have appropriate access to the admin dashboard. The test initializes with the before each hook, logging in as an admin user before each test to set the context. Next, we will write a test that checks if the admin user can successfully access the admin dashboard by visiting the admin URL. We validate this by asserting that the URL contains admin and that the admin panel is visible, confirming the admin's access rights. Following this, we need to ensure that a regular user does not have access to the admin dashboard. After logging out the admin user and logging in as a regular user, we attempt to visit the same admin URL. Here we assert that the URL does not include admin and that an error message indicating access denied appears, effectively demonstrating how the application restricts access based on user roles. This approach helps maintain both security and functionality, ensuring that users interact with the application within their designated permissions. Now let's take a look at how we can effectively test the loading states after user authentication using Cypress. In this example, we begin by logging in a user with specified credentials and confirming that the application redirects to the correct dashboard page. This step ensures that authentication flows correctly from login to user access. Next, we implement checks for a loading spinner, which indicates that data is being fetched in the background. The code asserts that this loading spinner is visible after the login action, ensuring users understand that their request is being processed. Following this, we assert that the spinner eventually disappears, confirming that the data has finished loading. This is vital for providing a seamless user experience, as it reassures users that they are not left in the dark during data retrieval. Finally, we verify that the relevant user data is present and visible on the page, cementing that the user sees the expected information post-login. This thorough approach to managing asynchronous operations ensures our application behaves robustly, enhancing the overall user experience by confirming that they see what they expect after logging in. Now let's implement enhanced assertions to improve the clarity and overall quality of our tests. Here, we create a test case that aims to validate the behavior of our application when a user tries to log in with incorrect credentials. We begin by calling a custom login command with a test username and a wrong password. This simulates an invalid login attempt. Next, we perform assertions on the error message that should appear in response to this invalid action. We first check that the error message is visible on the screen, confirming that the user receives feedback regarding their login failure. Then we assert that the message contains the text invalid username or password, which ensures that the app communicates the issue clearly. Finally, we add an additional layer of validation by asserting that the error message has a specific CSS class, error alert. This check not only verifies the presence of the message, but also the correct styling and classification, thus ensuring that the application adheres to the designed user experience. This practice of comprehensive assertions significantly aids in identifying issues quickly during testing and enhances the maintainability of our test code. In conclusion, the assertion of application states is not just about checking if something is there. It's about validating the entire user experience, ensuring that users receive appropriate feedback, and confirming that data is loaded and managed correctly. By utilizing Cypress effectively, we can create high-quality tests that cover various scenarios, from user authentication to role management and data loading. As you continue to explore the capabilities of Cypress, remember the importance of crafting meaningful assertions that reflect real user interactions. This approach will lead you to build software that not only works as intended, but also delivers an exceptional user experience. Now let's take a look at how we can define a BDD scenario for user registration using Gherkin syntax. The feature user registration describes the functionality we want to implement, focusing specifically on the user receiving a welcome email after completing registration. Within this feature, we outline a scenario that captures the sequence of events. First, the user fills out the registration form, then submits it, and finally, expects to receive a welcome email. The scenario is written in a clear, structured manner that is easily readable by both technical and non-technical stakeholders. Each step in the scenario uses familiar language to convey the actions taken during the registration process. As we define this scenario, we set the groundwork for writing automated tests in Cypress, which will verify that the application behaves as expected. With this scenario outlined, developers can proceed to implement the corresponding steps in their testing framework, ensuring a tight alignment between business requirements and the technical code. This approach not only clarifies expectations, but also enhances collaboration among team members throughout the development cycle. Now let's implement the following step in our Cypress test framework to verify that users receive a welcome email after registration. This code defines a step in our test scenario where we check if an email has been received by the user. In this snippet, we start by specifying that when the condition of the user receiving a welcome email is met, we will run a series of commands to confirm it. First, we use task getLastEmail to dummy@example.com, which communicates with a custom task defined in our Cypress configuration. This task is responsible for querying our email service and fetching the most recent email sent to the address provided, in this case, a mock email address. Upon retrieving the email, we then use a promise resolution with then email equals to extract the email details. Inside this promise, we use an assertion with expect email subject to equal welcome to our service to check that the subject line of the email is exactly what we expect. This assertion validates that our application correctly sends a welcome email upon user registration, thus ensuring our feature works as intended within the context of our test. Another key aspect of BDD is the procedure of collaborative testing through a continuous feedback loop. As developers implement features, they can frequently run BDD tests that validate that their changes meet business expectations. Continuous integration tools can automate the running of these BDD tests, providing immediate feedback to the team whenever the application is modified. For effective implementation, maintain an up-to-date suite of BDD scenarios. Encourage team members to write new scenarios as they emerge, adapting to any changes in the software's functionality or stakeholder requirements. Using version control helps track changes in scenarios, ensuring the entire team is aligned throughout the software's lifecycle. Likewise, when running tests in Cypress, it's beneficial to utilize its powerful dashboard capabilities. You can visualize test runs, see which tests pass or fail, and even capture screenshots or videos of test failures. This visual representation helps in quickly debugging any issues with the application and fosters a shared understanding of current project status. Finally, let's summarize what we've covered. We discussed behavior-driven development as an effective methodology that enhances collaboration and communication among technical and non-technical stakeholders. We explored Gherkin syntax and how to write clear test scenarios that reflect business requirements. We also learned about Cucumber's role in enabling BDD within Cypress, along with practical examples of how to implement BDD scenarios and corresponding step definitions that execute tests. In the next lesson, we will dive into more advanced topics related to Cypress, such as test data management, interacting with REST APIs during tests, and integrating end-to-end tests with CI/CD pipelines. Understanding these concepts will further enrich your testing capabilities and improve the overall quality of your software products. With BDD as a guiding principle, you can create not only robust tests, but also ensure that everyone involved in the development process is aligned and working towards the same goals. As you implement these practices, keep the spirit of collaboration and continuous improvement at the forefront of your testing. Cucumber is a powerful tool that plays a pivotal role in bridging the gap between technical teams and business stakeholders within Agile environments. It streamlines interactions and clarifies expectations, ensuring everyone is on the same page when it comes to software requirements. So far, we learned about behavior-driven development, BDD, as a collaborative methodology that enhances understanding between stakeholders by using Gherkin syntax to define clear test scenarios. We explored how to implement these scenarios in Cypress, ensuring alignment between business requirements and technical execution through practical examples. Additionally, we discussed the importance of maintaining an updated suite of BDD scenarios and utilizing continuous integration tools for feedback. In the next lesson, we will cover advanced Cypress topics like test data management and integrating tests with CI/CD pipelines. Today, let's delve deeper into Cucumber and its integration with Cypress for efficient testing. Cucumber allows teams to define how an application should behave using a format called Gherkin, which is easily readable and understood by everyone, from developers to managers. The strength of Cucumber lies in its ability to facilitate communication, as it transforms software requirements into a shared language all stakeholders can discuss. Now let's see how we can implement the login scenario from our Gherkin file in Cypress. We start by setting up a test suite using the describe function, which groups the tests related to user login. Inside this suite, we define an individual test case with the it function, clearly describing its expected behavior, redirecting the user to the dashboard upon a successful login. Next, we use the visit command to navigate to the login page, aligning with the initial step defined in our Gherkin scenario. Following this, we simulate user actions by selecting input fields for the username and password using the get method to target these elements, and then invoking the type function to input the valid user credentials. Finally, we submit the form using get form submit and assert the expected outcome with URL should include dashboard, ensuring that the application behaves as intended by confirming the successful redirection. This Cypress test effectively mirrors the defined behavior in the Gherkin syntax, establishing a clear link between the business requirements and technical implementation. Now let's implement the following test code that encapsulates the login functionality we outlined in our Gherkin scenario. We start by using the describe function to group our test cases, providing a clear context, in this case, user login. This method helps in organizing your tests and allows for better readability. Inside the describe block, we define a specific test case using the it function. Here, we describe what the test is expected to validate, in this case, that the application should redirect the user to the dashboard upon successful login. We first navigate to the login page using visit, mimicking the user experience by loading the correct page. Next, we interact with the user interface by targeting the input fields for the username and password using get, where we specify input names to access these elements accurately. We simulate user behavior by providing valid credentials using the type function, which helps automate the input process in a user-like manner. After entering the credentials, we simulate the submission of the login form. Finally, we use URL should include dashboard to assert that the user is redirected to the dashboard, confirming the expected outcome. This complete cycle validates that the login feature functions correctly as intended. Now let's see how we can integrate Cucumber with Cypress by installing the necessary package and configuring our project. Start by running the command to install Cypress Cucumber Preprocessor as a development dependency. This package enables Cypress to process Gherkin syntax, allowing us to create feature files that define our application's behavior in an easily readable format. Next, we will configure Cypress to recognize the syntax by creating a new JavaScript file in the Cypress/plugins directory, specifically index.js. In this file, we will import the Cucumber preprocessor and set it to process any files with a feature extension. This setup is crucial because it allows Cypress to handle our Gherkin feature files whenever they are encountered during testing, streamlining the workflow for running automated tests based on defined scenarios. By establishing this integration, we create a clear pathway from requirements specified in Gherkin format to executable tests in Cypress, enhancing both maintainability and collaboration among team members. Now let's implement the step definitions for our login scenario using Cypress and Cucumber. We begin by importing the necessary functions, given, when, and then, from the Cypress Cucumber preprocessor. This allows us to define behavior associated with each step in our Gherkin scenario. Next, we describe the context of the scenario by defining a given step. The user is on the login page. In this step, we utilize the visit command to navigate to the login page of our application, ensuring our test starts from the correct state. We then move to the when step, where we detail the actions the user should take. Here, we simulate user input by selecting the username and password fields and using the type function to enter valid credentials for both. Finally, in the then step, we assert that the expected outcome occurs. The URL should include dashboard command checks whether the user is redirected to the dashboard after a successful login, effectively confirming the functionality works as intended. This structured approach enhances collaboration and understanding between technical and non-technical stakeholders, reinforcing the benefits of using BDD with Cypress. Now let's implement a scenario outline for user login attempts using Cucumber with Cypress. This innovative feature allows us to test multiple sets of data within a single scenario, streamlining the testing process and reducing code duplication. In this outline, we define the overall structure of the login attempt scenario, beginning with the given step that sets the context, ensuring the user is on the login page. The when step is key, as it introduces placeholders for the username and password inputs, allowing us to customize the test based on different user credentials. We then define our expected outcomes in the then step, which checks that the user is redirected to the appropriate page based on the input. Furthermore, the examples section is where we provide specific combinations of usernames, passwords, and the corresponding redirect pages. This enhances the robustness of our tests by covering various scenarios, such as valid and invalid login attempts, in one concise outline. By utilizing scenario outlines, we improve our test efficiency and clarity, as each variation in input is automatically executed through the framework. This results in a comprehensive and maintainable test suite that accurately reflects user experiences. Now let's implement the following step definitions that correspond to our scenario outline for user login attempts. We start by importing the necessary functions from the Cucumber preprocessor, which allows us to define our given, when, and then steps in a structured manner. First, we define the given step, which sets the context by directing the user to the login page using Cypress's visit function. This ensures that every test starts from the correct state. Next, we implement the when step, which captures user input for both username and password as parameters. By utilizing template strings, we dynamically insert the values into the input fields, allowing for flexibility with different scenarios defined in our outline. Finally, we establish the then step, where we assert that after the login action, the user is redirected to the expected page. The use of the URL should include redirect page. Command verifies that the URL contains the expected path, providing clear feedback on the test's success. This structured, organized approach minimizes code repetition and maximizes coverage, thus ensuring a more maintainable test suite. Now let's implement a GitHub Actions workflow to automate our Cypress tests every time we push code to the repository. The workflow begins with a name declaration, clearly indicating its purpose, which is to run continuous integration tasks. This configuration triggers on a push event to the repository, meaning anytime code is pushed, it will initiate the testing process. The workflow consists of a single job called test that will run on the latest version of Ubuntu, ensuring compatibility with most node packages and Cypress itself. Next, we define the steps that GitHub Actions should take during this job. The first step checks out the code from the repository, enabling access to the latest version of our application. Following that, we install the project dependencies with the npm install command, ensuring that all necessary packages are available for the test execution. Finally, we run our Cypress tests using the npm run test command, which executes the testing scripts defined in our package JSON file. This automation not only increases productivity, but also ensures that developers receive immediate feedback on their code changes, helping to catch errors early in the development lifecycle. In conclusion, using Cucumber for testing is an effective method for aligning technical and business understanding within Agile frameworks. By adopting Gherkin syntax for writing clear, human-readable specifications, teams can foster better communication and collaboration. The integration of Cucumber with Cypress further enhances this synergy, allowing for seamless end-to-end testing that accurately reflects business needs. By leveraging scenario outlines, maintaining organized step definitions, and automating continuous integration, your testing strategy becomes not only robust but also scalable. So remember, the goal of testing is not just to catch bugs, but to understand and validate what you're building is genuinely aligned with user expectations. As we continue to explore more advanced topics in Cypress, keep in mind the solid foundation that Cucumber and BDD provide, leading us towards a more productive and positive development environment. Now let's gear up for our next session, where we'll delve into managing test data and improving our CI/CD pipeline integration for an even more seamless testing experience. Visual regression testing is an essential technique for ensuring that the visual appearance of an application remains consistent after code changes. It's a straightforward way to catch unintended changes that might affect the layout and design of your application, allowing for a higher quality user experience. In this session, we will dive deep into the concept of visual regression testing, its significance, how to implement it using Cypress, and the tools that can aid in achieving seamless visual testing. So far, we learned that Cucumber is a valuable tool for bridging the communication gap between technical teams and business stakeholders, using Gherkin syntax to define software behavior in a clear and collaborative manner. We explored how to implement Gherkin scenarios in Cypress for efficient end-to-end testing, emphasizing the importance of maintaining clear structure and organization in our tests. Additionally, we discussed the advantages of scenario outlines for testing multiple cases and the role of continuous integration in enhancing the testing process. As we move forward, we will explore visual regression testing and its important role in maintaining our application's visual integrity. Now let's see how we can implement the Cypress Image Snapshot plugin, which is essential for our visual regression testing setup. First, we need to install the plugin as a development dependency in our project. This allows us to leverage its features for capturing and comparing visual snapshots during our tests. By running the command to install the plugin, we ensure that it's properly integrated into our Cypress environment. After the installation, it's important to configure the plugin so that it can be accessed throughout our test suite. To do this, we open the Cypress/support/index.js file and include an import statement for the plugin's commands. This line of code sets up the necessary functionality that allows us to use image snapshot commands across all our tests, enabling the seamless comparison of visual states against baseline images. With these steps completed, we have established a robust foundation for visual regression testing in Cypress. This setup will facilitate accurate and efficient visual comparison, helping us maintain the visual integrity of our applications as we continue to develop and enhance them. Now let's implement the following test case to create our first visual regression test. The test begins with a describe block that names the test suite Visual Regression Testing, allowing us to group related tests together for better organization. Within this suite, we focus on a specific test case defined by the it block, which describes the functionality we are testing, ensuring that the homepage snapshot matches the expected visual state. Next, we use the visit/ command to navigate to the homepage of our application. This simulates a user accessing the website, and it's crucial for capturing accurate visual data. To ensure the page has fully loaded before we take our snapshot, we include a wait 1000 command, which pauses the execution for 1 second. Following that, we assert that the main heading, represented by an H1 element, is visible on the page. This check confirms that the expected content is present and the page is rendered correctly. Finally, we call document to match image snapshot, which takes a visual snapshot of the current state of the homepage. This command compares the newly captured screenshot with the baseline image stored from the previous run, allowing us to detect any unintended visual changes caused by recent code updates. By incorporating this test, we enhance our application's visual integrity and maintain a consistent user experience. Now let's see how we can run our Cypress tests to effectively capture visual snapshots. To execute the tests you created, open your terminal and enter the command npx cypress open. This command launches the Cypress test runner, which provides a graphical interface for managing and running your test files. Once the application is open, navigate through the interface to locate the test file you previously created, such as Visual Regression, spec.js. After selecting the test file, click to run it. If your recent modifications have resulted in any visual discrepancies from the baseline images, Cypress will compile and present a detailed report highlighting the differences between the newly captured images and the stored snapshots. This immediate feedback is invaluable, allowing both developers and designers to quickly identify any unintended alterations to the user interface and maintain visual consistency across the application. By capturing these insights in real time, we can ensure that the visual integrity of our application remains intact throughout its development lifecycle. Now, let's implement the following configuration options to enhance our image comparison in visual regression testing. The to-match-image snapshot method can be customized with various parameters that allow us to fine-tune how differences in visual appearance are detected. We start with the failure threshold, set to 0.1, which determines the permissible percentage of pixel differences between the current snapshot and the baseline image. This means that if the visual changes between the images exceed this threshold, the test will fail, indicating that there might be a significant difference worth investigating. Next, we specify failure threshold type as %, reinforcing that our threshold is measured in percentage terms. This provides a clear metric for evaluating visual discrepancies. Additionally, we can introduce a custom diff config, where we set a specific threshold of 0.1 to control the sensitivity of visual differences. By adjusting this value, we can emphasize or de-emphasize the importance of minor visual changes. Lastly, the capture option is set to viewport, allowing us to choose whether to capture the entire viewport or focus on a specific element. This flexibility is crucial when certain dynamic components might change frequently, helping us maintain the integrity of our visual regression tests. Now let's see how we can manage our baseline images effectively when running visual regression tests. The command npx Cypress-Run update snapshot equals true plays a crucial role in updating the baseline images stored in our project. By executing this command, we instruct Cypress to run our tests with the update snapshot flag set to true, allowing it to replace any existing snapshots with newly captured images. This is particularly important as your project's user interface evolves over time. With every improvement or feature addition, visual changes may occur that necessitate updating the baseline images. It's vital to proceed with caution when using this command, as it will overwrite your previous snapshots. Therefore, it's recommended to ensure that the new visual state of the UI matches your expectations before running this command. By incorporating this step into your workflow whenever significant changes are made, you can maintain an accurate set of visual references, ultimately supporting better visual regression testing and helping to safeguard the quality of your application's user experience. Now let's take a look at how we can configure a continuous integration workflow using GitHub Actions to automate our visual regression testing process. In this YAML configuration, we define a workflow named CI that triggers on pushes to the main branch. The workflow consists of a job named test, which runs on the latest version of Ubuntu. Next, we outline the steps to be executed in the job. The first step is to check out the source code from the repository, enabling the subsequent steps to access the files that are being tested. After the code is checked out, we set up the Node.js environment by specifying the version needed for our project. This step is crucial for running JavaScript-based tests. Following that, we install the project dependencies by running npm install, ensuring all necessary packages are available for our tests. Finally, we execute our Cypress tests with the command that runs the tests, but also includes an environment variable to disable snapshot updates, preserving the existing baseline images. By integrating this workflow into our CI pipeline, we ensure that every code change is automatically tested for visual discrepancies, contributing to a more reliable and consistent user experience in our application. To wrap it all up, visual regression testing is an immensely powerful method for maintaining the visual integrity of your applications. By leveraging tools such as Cypress Image Snapshot, we can capture and compare the visual states of our applications, ensuring that any changes do not affect user experience negatively. Visual regression tests help in delivering a polished, visually consistent product. As we have covered, we can define tests to capture snap views of our application, manage baseline images effectively, and integrate these tests into our CI/CD pipeline for continuous feedback. With visual regression testing, you're not just writing tests, you are building confidence in the visual consistency of your application, delivering a product that meets user expectations seamlessly. Stay tuned for our next lesson where we will dive into more advanced test, data management strategies, and CI/CD integrations. By the end of this segment, you will be well prepared to tackle complex testing scenarios with. Now let's take a look at a simple CI pipeline configuration using GitHub Actions, which will automate our testing process every time there are code changes in the main branch. The workflow begins by specifying that it will be triggered upon pushes to the main branch, ensuring that any updates made are automatically processed. Next, we define a job named build, which will run on the latest version of Ubuntu, providing a stable environment for executing our tasks. The first step in this job is to check out the latest code from the repository. This is essential as it ensures that the pipeline operates on the most up-to-date version of your application. Moving on, we set up the Node.js environment required for our project, specifying the version needed. This guarantees that our dependencies and build process align with the correct runtime. Then we install the necessary project dependencies specified in the package JSON file, ensuring everything is ready for testing. Finally, we execute our tests using npm, which runs the defined test cases and provides immediate feedback. If any of these steps fail, the developer is notified right away, preventing any faulty code from being merged into the main branch and ensuring a stable build. Now let's implement a more comprehensive CI/CD pipeline that integrates both testing and deployment to enhance our workflow. The configuration starts by defining the workflow name and the trigger, which specifies that the pipeline will activate upon pushing code to the main branch. This is crucial because it ensures that every code change is subject to the CI/CD process, keeping the application stable. Next, we define a job that runs on an Ubuntu environment where multiple steps will be executed sequentially. First, we check out the code from the repository, enabling the pipeline to access the latest version of the application. Following this, we set up the Node.js environment, specifying the version needed for the application. This is essential for ensuring compatibility. Once the setup is complete, the pipeline runs the necessary commands to install project dependencies and execute tests. Importantly, after all tests have passed successfully, we transition to deploying the application. This involves synchronizing the build output to an Amazon S3 bucket, where the application becomes immediately accessible in production. By utilizing environment variables for Oz credentials, we ensure a secure deployment process, emphasizing the best practices of maintaining sensitive information. Through this configuration, we create an automated flow that not only tests code but also rapidly deploys it, embodying the essence of continuous deployment. Now let's see how we can incorporate Cypress into our CI workflow to run automated tests effectively. In this code setup, we begin by specifying that our job will run on the latest version of Ubuntu. The first step is checking out the code from the repository, ensuring that we have the most up-to-date version that we want to test. Next, we set up the Node.js environment, allowing us to utilize Node.js version 14 for our application. This step is critical since our application depends on this specific version of Node.js to run properly. Following that, we install all necessary dependencies using npm, which is essential for ensuring that our application has all the required packages to function. After installing dependencies, we initiate the application in the background, which is important because Cypress needs the application running to execute its tests against it. Finally, we run the Cypress tests using the command npx cypress run. This command will execute all the defined tests, allowing us to validate whether our application behaves as expected. This entire workflow not only enhances the efficiency of our testing process, but also safeguards the code quality before any deployments take place. So far, we've walked through an overview of CI/CD, established the criticality of integrating Cypress into our CI/CD pipelines for testing, and outlined practical examples of how to create these workflows in GitHub Actions. It is crucial to bear in mind that CI/CD is not just a set-it-and-forget-it process. Rather, it requires continuous maintenance and improvement as the project evolves. Now we will talk about common pitfalls to avoid when implementing CI/CD practices, as well as techniques to effectively manage concurrent tests, ensuring that your testing suite remains efficient as your application scales. One frequent mistake is allowing the growth of flaky tests that unpredictably pass or fail. Properly configuring your testing framework and adhering to well-defined testing standards can help mitigate this risk. Additionally, using Cypress in combination with other testing libraries can provide more comprehensive coverage for your applications. For instance, leveraging tools like Jest for unit testing and Cypress for end-to-end testing can lead to an effective testing strategy that covers all bases, from single components to user journeys within your app. The balance between unit tests and integration tests is essential, as it minimizes overhead during merges while ensuring that every aspect of the application is functioning as intended. In conclusion, implementing CI/CD using Cypress allows you to automate testing, enhance code quality, and deliver updates efficiently. With a solid CI/CD strategy, your development team can be more agile, iterate faster, and ultimately provide more value to your users. This ongoing cycle of testing, integration, and deployment not only streamlines development processes, but also fosters a culture of continuous improvement, a true win-win for any modern development. In today's lesson, we're diving deep into the role of Cypress in continuous integration and continuous deployment, or CI/CD. As we learned, in order to continuously integrate code changes, there should be tests in place. Testing plays a pivotal role in this process, as it validates that our applications run smoothly and as intended. We'll explore how Cypress enhances the efficiency and reliability of this crucial stage in software development. Now let's take a look at how we can define a basic test using Cypress. In this example, we start by creating a test suite with the describe function, which groups related tests together. Here, we're focusing on testing the homepage of our application. Inside this suite, we define a specific test case using the it function, indicating the expected behavior, in this case, that the homepage should load successfully. Within the test case, the visit command instructs Cypress to navigate to the URL of our application, specifically targeting http://localhost 3000. This is the address where our application will be running locally. After the page loads, we use the contains command to assert that a specific string, welcome to my app, is present on the home page. This serves as a validation check to ensure that the page loads correctly and contains the expected content. By integrating this test into our CI/CD pipeline, we can automate the checking process, providing ongoing assurance that our homepage remains functional with every code change made. Now let's see how we can implement a CI pipeline using GitHub Actions to ensure our Cypress tests run automatically whenever we push changes to the main branch. The configuration begins by naming our workflow and defining the trigger that initiates the pipeline upon a push event to the specified branch. This ensures that any code changes are tested immediately, maintaining the stability of the application. Next, we set up a job called test, which will execute on an Ubuntu latest server to run our tests in a consistent environment. The steps within the job are critical. First, we check out the latest code from the repository to ensure our tests run on the most recent code changes. Then we set up Node.js, which is essential for our application's execution. After installing the project dependencies using npm, we start the application with the npm start command. The inclusion of the and at the end of this command allows it to run in the background, freeing up the job to continue to the next step. Finally, we execute the Cypress tests using npx cypress run, ensuring that our application's functionality is validated with every new code deployment. Now let's see how we can implement a login functionality test in our Cypress setup. In the code, we start by defining a test suite called login functionality. This suite will contain individual test cases related to the login feature of the application. Using the before each function, we ensure that before every test runs, we load the user data from the user.json fixture file. This allows us to avoid hard-coded credentials, promoting better maintainability. Once the data is loaded, we store it in this user for easy access throughout our test cases. Now in the actual test case, we simulate a user visiting the login page of the application. We then enter the username and password by targeting their respective input fields and utilizing the type command to simulate user input. After filling in the credentials, we trigger a form submission by clicking the Submit button. Finally, we include assertions to validate that the user is redirected to the dashboard after a successful login. We check that the URL includes dashboard, and we confirm the presence of a welcome message. This structured approach to testing enhances readability and ensures that any changes to the user data in the user.json file are automatically catered for throughout our test journey. Now let's see how we can implement a test that ensures our application fetches and displays data correctly. In this example, we use Cypress to intercept a GET request to the /API/data endpoint. By utilizing the intercept command, we can mock the network request and specify that it should return a fixture file named data.json. This is crucial because it allows us to control the data that our test receives, ensuring stability and consistency during test execution. Once we've set up the interception, we navigate to the relevant page of our application using visit, directing the test to load the data view. To ensure the mock response is processed, we include a wait command which waits for our previously established alias at getData to be called, confirming that the data has been fetched. Finally, we locate the elements that should reflect our data on the page using get, asserting that the length of the displayed items matches our expectations. In this case, we check that there are exactly 5 data items displayed. This approach minimizes dependencies on the actual API, promoting more stable and reliable tests in our CI/CD pipeline. Now let's implement the following configuration in our Cypress-JSON settings file to enhance our logging and debugging capabilities during CI/CD runs. By setting the video option to true, we enable Cypress to record videos of our test runs automatically. This feature is particularly useful for identifying failures in the CI environment, as it allows you to review exactly what happened during the test execution. However, to optimize storage and focus on critical failures, we set video upload on passes to false. This means that videos will only be uploaded to the CI/CD platform if a test fails, preventing unnecessary clutter of successful test runs. With this setup, you can easily troubleshoot issues that arise in your CI processes without overwhelming your storage with successful test videos. This efficient use of resources helps maintain a clean CI environment while still providing valuable insights into potential problems within your application. Now, let's see how we can implement parallel test execution using GitHub Actions with Cypress. This configuration allows us to run our tests across different browsers simultaneously, enhancing the efficiency of our CI/CD pipeline. In the YAML file, the job is defined under jobs, with test being the job name that specifies it runs on the latest version of Ubuntu. We utilize a matrix strategy, which enables us to run the tests in both Chrome and Firefox. This means that instead of bottlenecking our testing process by running tests sequentially in one browser, we can now execute them in parallel across different environments. The first step checks out the code from the repository, ensuring we're testing the most recent changes. Next, we set up Node.js version 14, which is essential for running our application and tests. After installing the necessary dependencies through npm, we proceed to run the Cypress tests. The command includes a dynamic reference to the current matrix browser, allowing the tests to be executed in both Chrome and Firefox simultaneously. This approach significantly speeds up the feedback loop by making the most of our CI resources. As we conclude, it's clear that the integration of Cypress within CI/CD workflows is substantial in maintaining software quality and streamlining the development process. By effectively leveraging Cypress, you can ensure that your application remains stable despite constant changes and feature additions. To recap, we explored how Cypress aids in automating tests, integrated those tests into CI pipelines, organized our test files efficiently, managed flaky tests through intercepting APIs, enabled logging and debugging capabilities, and even discussed parallel test execution. With these tools and strategies, you're on your way to becoming a CI/CD testing whiz with Cypress. Embrace these practices and watch your development cycles accelerate, allowing for more innovation and faster delivery to your users. Now go ahead and rock that. Now that we've checked and verified that our tests are ready to run in a CI/CD environment, we will set up the CI/CD pipelines. In this video, we will take a deep dive into defining and configuring CI/CD pipelines, which are essential for automating the deployment process in modern software development. So far, we learned about the importance of Cypress in CI/CD workflows, highlighting its role in automated testing to ensure application stability during changes. We explored how to integrate Cypress with CI pipelines using platforms like GitHub Actions, including setting up configurations for running tests. We also discussed organizing test files, managing flaky tests through network intercepts, enabling advanced logging and debugging capabilities, and running tests concurrently for efficiency. These practices equip you to maintain software quality and streamline the development process effectively. Now we will cover how to set up CI/CD pipelines that will automate these processes, making your workflow smoother and more efficient. Now let's take a look at the initial structure of our CI/CD pipeline configuration. This YAML file begins with the name key, which defines the title of the pipeline, in this case, CI/CD pipeline. Following this, the on key specifies the events that trigger the pipeline, allowing automation upon pushes to the main branch or when pull requests are open targeting it. This is critical for ensuring that the latest changes are tested and integrated effectively. Next, we outline the jobs section, where we define a single job called build that runs on the latest version of Ubuntu. This indicates that our CI/CD workflow will execute in a consistent and reliable environment, which is essential for maintaining code stability. By separating our configurations in this manner, we lay a solid foundation that will allow us to easily expand our pipeline with further steps, such as installing dependencies or running tests. This setup not only creates an organized structure, but also sets the stage for a seamless deployment process, enhancing overall productivity in our development workflow. Now let's see how we can implement the cost structure of our CI/CD pipeline using GitHub Actions. First, we define the name of our pipeline, which sets an identifiable title for our workflow. The on section specifies the trigger events that will initiate the pipeline, specifically pushes and pull requests targeting the main branch. This ensures that our tests run automatically whenever code is pushed, enhancing our responsiveness to changes. Next, we outline a job called build that will execute in a fresh Ubuntu environment. The job comprises several essential steps. We begin by checking out the latest version of the code using Actions Checkout at v2, allowing access to our repository's contents. Following this, we configure the environment for Node.js, specifying the version to use, which is essential for both our application code and Cypress tests. Later on, we install all necessary dependencies with the npm install command, ensuring that our environment has everything it needs to run smoothly. Afterward, we start the application in the background, enabling the pipeline to proceed without waiting for the app to fully initialize. Finally, we execute our Cypress tests with npx cypress run, providing immediate feedback on the test's outcomes, which is vital for maintaining application quality during development. Now let's take a look at how to incorporate environment variables securely in our CI/CD pipeline setup. In the provided YAML configuration, we specify a command that runs the Cypress tests while passing a sensitive credential, database URL, as an environment variable using GitHub secrets. This command utilizes the syntax secrets. Database URL, allowing us to reference the encrypted secret stored securely in the GitHub repository settings without exposing it in the source code. This method ensures the credentials remain safe, adhering to best practices for managing sensitive information. By using environment variables, we can easily switch configurations for different environments such as development, staging, or production without modifying the codebase directly. Proper management of these variables simplifies the setup and maintenance of your CI/CD pipeline, making it both secure and efficient. In this step, we fortify our testing process by ensuring that Cypress has access to the necessary credentials to run tests that may require database interactions, all while keeping those details hidden from anyone who might view the repository. Now let's implement a custom logging feature in our Cypress tests. By adding a custom command called log, we enhance the clarity and detail of our logs during test execution. This command utilizes Cypress's built-in logging capabilities to output messages that inform us about the current state of our tests. The custom log function takes a message as an argument and relays it through Cypress's logging system, ensuring that all relevant information is captured in the test logs. Next, we will integrate this logging functionality into our test suite. In the test case for logging in, we will use our custom log function to track the navigation process and user actions, such as visiting the login page, entering credentials, and clicking the login button. Each key action is followed by a log statement that captures the flow of operations, providing immediate visibility into what is happening at each step. This structured logging approach not only aids in debugging, but also delivers a robust overview of the test execution, making it easier to identify where potential issues may arise. By adopting this practice, you'll enhance the feedback mechanism during your CI/CD runs, allowing for quicker diagnoses and resolutions. Now let's implement the following configuration to set up our CI/CD pipeline for running tests efficiently across multiple browser environments. In this YAML configuration, we define a job named test that runs on the latest version of Ubuntu, ensuring a compatible environment for our application. Under the strategy key, we introduce a matrix that allows us to specify multiple browser versions, Chrome and Firefox, in our configuration. This matrix strategy enables the pipeline to run our tests concurrently, drastically reducing the overall time for test execution. Next, we proceed to define the necessary steps for our job. We begin by checking out the code from the repository using GitHub's Actions Checkout action, which ensures that our pipeline has access to the latest changes. Then we set up Node.js using Actions Setup Node, specifying the required version, which is essential for executing our application and its tests. Following that, we install all project dependencies with npm install. To ensure our application is running while tests are being executed, we start the application in the background. Finally, we run the Cypress tests specifically for the browser specified in the matrix. This setup allows us to comprehensively test our application's compatibility across different browsers in parallel, enhancing our testing efficiency. Now let's implement the following step to automate deployment to Heroku after our tests have successfully passed. In this part of the CI/CD pipeline, the code sets up the Heroku remote repository and pushes the latest changes to it. First, we use the command to add the Heroku remote repository by specifying the URL of your Heroku app. This remote link is crucial as it tells Git where to deploy the code. Following that, we execute a push command targeting the Heroku repository's main branch, transferring all committed changes. It's important to note the inclusion of an environment variable, which uses the Heroku API key stored as a secret in GitHub. This ensures that sensitive information remains secure and isn't hard-coded directly into the pipeline. By automating this deployment step, your application remains continuously updated with the latest code changes. This integration with GitHub Actions captures the essence of a robust CI/CD framework, as it streamlines the deployment process and fosters a reliable delivery pipeline for your applications. This brings us to the conclusion of our exploration into defining and setting up CI/CD pipelines. We covered a lot of ground, including what CI/CD pipelines are and why they matter. We emphasized the integration of Cypress within these pipelines to automate testing and improve software quality. We configured a GitHub Actions pipeline step by step, learned best practices for managing secrets and environment variables, improved logging for better debugging, and gained insights into parallel job executions for efficiency. Lastly, we touched on automating deployments to services such as Heroku. You now have the knowledge and tools to build and configure your own CI/CD pipeline, helping you continuously integrate, test, and deploy your applications smoothly. Embrace these practices, and you'll be well on your way to innovating and deploying with confidence. Happy. To get started with the Cypress dashboard, go to https://dashboard/cypress.io/ and create a free account there. This essential initial step will allow you to access a multitude of features that enhance your testing experience. In this video, we're diving deep into setting up the Cypress dashboard, a powerful tool that will take your testing strategy to the next level. So far, we learned about setting up CI/CD pipelines and the importance of automating the deployment process in software development. We explored how to configure GitHub Actions to run tests using Cypress, including managing dependencies, starting applications, and running tests for effective feedback. Best practices were discussed for handling environment variables and enhancing logging for better debugging. Lastly, we examined how to implement parallel jobs and automate deployments to services like Heroku, equipping you to seamlessly integrate, test, and deploy applications. Now, we will talk about the setup and configuration of the Cypress dashboard and how it seamlessly integrates with your CI/CD pipeline. First, let's walk through the sign-up process. When you navigate to the Cypress dashboard website, you are greeted with a clean and intuitive interface. The registration process is straightforward. You simply need to provide your email, create a password, and confirm. Once your account is created and activated through your email, you'll be ready to venture into the dashboard. As with any tool, the first step sets the stage for everything that follows. So remember, a good account setup leads to a smooth testing journey. Now let's take a look at the Cypress JSON configuration file, which plays a crucial role in setting up your Cypress project for automated testing. In this file, we specify key settings that dictate how Cypress will interact with your application. Next, we can see that the base URL is set to http://localhost 3000, which directs Cypress to where your application runs locally. This is important because it informs the tests where to navigate during execution. The projected is another significant field, as it ties your test runs to the Cypress dashboard, making sure that results are reported and tracked effectively. The configuration also includes paths like integration folder, pointing to where your test files are stored, and viewport settings for browser resolution control during tests. Additionally, environmental variables are defined under the env section. For example, API URL will let tests access your API, while code coverage helps with tracking the coverage metrics during test execution. Finally, the Experimental Studio flag enables a powerful new feature in Cypress, which enhances your testing capabilities even further. This careful setup ensures a smooth integration with the Cypress dashboard and enables efficient test execution across your CI/CD pipeline. Now let's see how we can run our tests using the command line. The command we will be executing is npx cypress run record key record key. This command initiates the Cypress test runner, which is crucial for executing your tests in a headless browser environment. The npx command is a package runner that comes with Node.js, allowing you to execute the Cypress CLI without globally installing it on your machine. By using Cypress run, you are telling Cypress to execute all the tests defined in your project. The record flag enables recording of the test run, which sends results to the Cypress dashboard, providing you with valuable insights into your test performance. It's important to remember to replace record key with the actual record key obtained from your Cypress dashboard setup. This key authenticates the connection between your test suite and the dashboard, ensuring that your results are appropriately logged. Once you execute this command, Cypress will execute your tests, and you'll be able to monitor the outcomes directly on the Cypress dashboard, which allows you to track your test status efficiently. Now, what's exciting about using the Cypress dashboard is the ability to see a wealth of information regarding your test runs. The dashboard provides insights on how long tests took, the status of each test, whether it passed, failed, or was skipped, the committer who ran the tests, and even which branch the tests were executed against. With historical data available over time, you can start filtering test runs based on committers, date ranges, and statuses to analyze patterns in your testing lifecycle. One of the advanced features of the Cypress dashboard is the handling of flaky tests. Flaky tests refer to tests that can yield inconsistent results, sometimes passing and sometimes failing without changes in the underlying code. A flake can undermine the confidence in your test suite, and it's crucial to identify these tests, which is where the dashboard can help you maintain clarity about the health of your test suite. Now let's see how we can implement the Cypress tests in our CI/CD pipeline using GitHub Actions. The configuration begins by defining a job named tests, which is set to run on a self-hosted runner, ensuring that we have complete control over our testing environment. Next, we establish a strategy that allows us to run tests in parallel across 3 different containers. This means we can execute multiple instances of tests simultaneously, significantly cutting down the total execution time. In the steps section, the first action is to check out the code from the repository, which is essential for running tests against the latest version of your app. Following this, we set up the Cypress testing action, specifying several parameters. By setting the start command to yarn start, we launch our application, and using waiton, we establish a dependency on the application's availability for testing. The most critical part here is enabling the dashboard features. We achieve this by setting the record attribute to true, which activates test result recording in the Cypress dashboard, and setting parallel to true for running tests across containers. This setup maximizes the efficiency of our testing process, ultimately leading to faster and more reliable deployments. By configuring environmental secrets within your CI/CD pipeline, you can also securely manage sensitive information. It's a good practice to inject an environment variable named Cypress record key, which holds the project's record key, and a GitHub token that is automatically set by GitHub Actions to distinguish between different builds. This keeps your testing environment clean, organized, and secure. As your CI pipeline works its magic, you'll enjoy the benefits of load balancing. Cypress intelligently learns which tests perform better on which machines. Over time, this not only boosts efficiency, but also optimizes the overall execution of your testing strategy. Imagine running specific tests on Chrome across several CI machines while simultaneously executing others on Firefox. Cypress enables that, and the dashboard visualizes the results. Speaking of visualizing results, let's not forget about cross-platform support. Your Cypress tests can run on various operating systems, be it Linux, Windows, or macOS. This is particularly beneficial when your application is expected to function flawlessly across different environments. The Cypress dashboard will reflect the operating system that handled the tests, providing you with the clarity needed to catch any specific issues. Finally, leveraging the tagging system provided by Cypress allows you to organize your tests according to different environments. Whether you are testing on development, staging, or production, you can swiftly catch failing tests before they reach your customers. This proactive approach ultimately enhances the quality of your releases. In conclusion, setting up the Cypress dashboard might feel like a trivial task, but the insights and capabilities it offers are tremendous. From reducing testing times to providing a wealth of historical data, the Cypress dashboard integrates effortlessly into your CI/CD pipeline. It even enhances team collaboration by enabling tracking of test results across multiple committers and ensuring reliability through visibility. So I hope you're now equipped with all the necessary information to set up and benefit from the Cypress dashboard effectively. Remember, with a bit of setup, you'll not only ensure the health of your application, but also take a giant leap towards streamlined and robust testing practices. Thank you for joining me in this session, and I can't wait to see what you achieve with Cypress. To enable Cypress to send reports to the Cypress dashboard in your CI/CD pipeline, you need to integrate the two effectively. This integration allows real-time visibility into your test runs, empowering teams to make informed decisions about their development processes. In this lesson, we'll dive deep into how to seamlessly connect Cypress with your CI/CD workflow, optimizing your testing strategy. So far, we learned about creating a free account on the Cypress dashboard to enhance our testing experience. We discussed the process of setting up a project, configuring the project settings, and running tests while monitoring their results on the dashboard. Furthermore, we explored the benefits of integrating Cypress into a CI/CD pipeline, including parallel test execution and managing environment variables securely. Lastly, we highlighted the importance of visualizing test results and leveraging features like tagging and cross-platform support to improve testing efficiency and quality. Now, we will cover the step-by-step process of setting up that integration smoothly. To start, you need to ensure that your project is configured correctly for CI/CD. This involves not just having Cypress properly set up, but also ensuring that you have access to your CI provider's environment. Whether you're using GitHub Actions, Circle CI, or any other CI system, the good news is that Cypress has plugins and tools that make integration straightforward. First things first, ensure that the Cypress environment has access to necessary configurations by using secrets. In GitHub Actions, you can set environment variables securely, which is crucial for holding sensitive data like your Cypress record key. To configure this, navigate to your GitHub repository, select Settings, and then go to Secrets and Variables. Add a new secret for your Cypress record key that you obtained from the Cypress dashboard. For example, you can name it Cypress record key. Keeping sensitive information in GitHub secrets ensures that your CI/CD pipeline runs securely. Now, this key will be available to your action during the workflow execution without exposing it in your codebase. Now let's see how we can implement a GitHub Actions workflow to automate Cypress tests in our CI/CD pipeline. The configuration begins by defining the name of the workflow as Cypress tests and designating that it should trigger on push or pull request events specifically targeting the main branch. Next, we outline the job specifications for running Cypress tests, indicating that this job will execute on the latest version of Ubuntu. The steps are methodical. First, we check out the latest code from the repository, ensuring we are working with the most recent changes. Then we set up Node.js specifying version 14, which is crucial for running our JavaScript project and its dependencies. Following that, we install the necessary project dependencies, which is an essential step before starting the application. The server is then started in the background, allowing it to run while the tests are executed. It's important to set the node-env to test to ensure the application runs in the correct environment. Lastly, we utilize the Cypress GitHub action to run our Cypress tests. This action not only executes the tests, but also enables recording of test results to the Cypress dashboard, which is essential for tracking performance and visibility. Moving forward, let's evaluate the Run Cypress Tests step. This is where the Cypress dashboard integration becomes essential. The uses Cypress.io/GitHub action at v2 line highlights the specific action you are utilizing from Cypress. Not only does it simplify running your tests, but also automatically handles reporting to the Cypress dashboard when you provide the record and key attributes. This integration sends the results of your tests back to the dashboard, so you can track the success and failures of your code in real time. Make sure to correctly set up the wait-on parameter to allow the action to wait for your application to start up properly before Cypress tests are executed. This step helps mitigate flaky test failures due to timing issues, especially when the application isn't fully ready to serve requests. Now let's implement the following strategy to enhance our CI/CD workflow by leveraging matrix builds. This configuration facilitates running our tests concurrently across different operating systems and browsers, ensuring robust coverage of our application. By defining a strategy with a matrix parameter, we specify 2 operating systems, Ubuntu latest and MacOS latest, and 2 browsers, Chrome and Firefox. This setup allows the CI system to spin up multiple parallel jobs, effectively executing tests in each environment simultaneously. This not only accelerates the overall testing time, but also gives us a broader insight into how our application behaves across various platforms. As a crucial aspect of this parallelization feature, it's important to note that Cypress automatically tags each run with a unique build ID when provided with the parallel flag. This enables the Cypress dashboard to accurately associate test results with their respective runs, allowing for efficient tracking and management of feedback. By integrating this strategy, you can significantly improve your development feedback loops and enhance the quality assurance process in your CI/CD pipeline. Now let's take a look at how we can manage environment variables within our Cypress configuration. The snippet provided demonstrates how to define an object that belongs to the env key in your Cypress JSON file. Here we are setting two important variables, BIURL and nodenv. The API URL is particularly crucial, as it directs Cypress to the base URL of the API you will be interacting with during your tests, in this case, pointing to a localhost server for testing purposes. By setting nodenv to test, we further ensure that your application will run in the correct environment, allowing the application to behave as expected while tests are being executed. It's essential to remember that these configurations should align with the settings in your CI/CD pipeline. By using environment variables, you not only streamline the process of switching between different environments, like local and production, but also enhance security by preventing sensitive data from being exposed in your codebase. The implementation of these variables is a fundamental step for any automated testing strategy, particularly in the context of integration with CI/CD workflows. Now let's implement the following code snippet to enable video recording in your Cypress tests. By adding the key video true to your Cypress configuration file, you instruct Cypress to record a video of your test runs. This feature is incredibly beneficial for debugging, as it allows developers to playback the recorded videos and closely analyze the test execution when failures occur. When a test fails, the recorded video provides a visual context to the developers, showing exactly what was happening in the application at the time of the failure. This can drastically reduce troubleshooting time, allowing for more efficient resolutions without the need for prolonged discussions among team members regarding what transpired during the test. In environments where your tests are executed frequently, especially in a CI/CD pipeline, enabling video recording can enhance collaboration among team members, as everyone can access these recorded sessions to understand issues better. This approach not only supports maintaining high-quality code, but also improves the overall testing strategy within your development workflows. In conclusion, integrating Cypress into your CI/CD pipeline is not just about uploading results to a dashboard. It involves strategic configuration around environment management, parallel test execution, and employing best practices for handling flaky tests. By utilizing these features, you can ensure that your testing processes become not just efficient but also incredibly insightful, allowing your team to maintain high-quality software releases. As you embark on your Cypress journey, remember that the key to success is a well-integrated CI/CD pipeline that automates as much of the testing process as possible, providing immediate feedback and clear visibility into test performance. That ensures that quality remains at the forefront, regardless of how fast-paced your development lifecycle becomes. Now go ahead, implement these strategies, and watch your testing practices reach new. Welcome. Today we will explore the benefits of using the Cypress dashboard in your testing workflow. The Cypress dashboard is your command center for managing your test runs and performance, providing valuable insights that can enhance your continuous integration and continuous deployment processes. So far, we learned about integrating Cypress with CI/CD pipelines to enhance testing and reporting. We covered configuring CI environments, using GitHub Actions for automated test execution, and managing sensitive data securely with environment variables. Additionally, we explored how to implement parallel test execution and effectively handle flaky tests using video recordings for better debugging. Finally, we emphasized the importance of strategic configuration for achieving efficient, high-quality software releases. Now, we will dive into the benefits of the Cypress dashboard and how it revolutionizes the testing process. Now, let's see how we can set up our Cypress tests to be recorded and displayed on the Cypress dashboard within our GitHub Actions workflow. To do this, we will create a step in our CI configuration that utilizes the Cypress GitHub action. In this step, we declare the action to perform by specifying Run Cypress Tests, which identifies its purpose clearly. The action we will use is the cypressio/GitHub action at v2, a popular choice for integrating Cypress with GitHub Actions that automatically handles installation and configuration of Cypress for us. Next, we enable the recording feature by setting the record parameter to true. This tells the Cypress dashboard to capture the test results upon execution, which is vital for gaining insights into our test performance over time. Additionally, we include a key parameter where we reference the Cypress record key stored securely in our GitHub secrets. This secret key is essential for authenticating our test runs with the Cypress dashboard, ensuring that our results are pushed securely and efficiently. By configuring our workflow in this way, we can easily monitor the status of our test runs, allowing our team to identify and resolve issues swiftly. Now let's take a look at how we can format our test results within the Cypress dashboard for more meaningful insights. The JSON snippet we are examining provides a structure for logging individual test outcomes, which is crucial for understanding test performance. In this example, we have a test labeled "Users can log in successfully." This descriptive title helps anyone reviewing the results quickly grasp what functionality is being tested. The duration field indicates that this test took 2,000 milliseconds to execute. This metric is especially important as it allows the team to monitor trends over time. If execution times increase, it may signal a need for optimization or refactoring. Finally, we observe the status field, which denotes whether the test passed or failed. In this case, it shows passed, indicating the test ran successfully without any issues. By including such detailed breakdowns for each test, the Cypress dashboard empowers teams to analyze and refine their test suites continuously, leading to improved software quality and performance. Now let's implement the following configuration in your Cypress JSON file to enable video recording during your test runs. The first line specifies that video recording is enabled by setting the video property to true. This feature will automatically capture video recordings of your test runs, which can be incredibly useful for analyzing test failures and understanding their causes. The second line points to the folder where these recorded videos will be saved, defined by the Videos folder property. This not only organizes your test materials, but also ensures you know exactly where to find the videos when needed. If a test fails, you can review the corresponding video to see what occurred during the test run, which eliminates much of the guesswork involved in debugging. By combining these two configurations, you empower your development team with valuable visual feedback that can significantly accelerate the debugging process and improve the overall reliability of your testing efforts. With these recorded insights at hand, tackling flaky tests becomes more manageable, facilitating a smoother development workflow. Now let's take a look at how we can categorize our tests effectively using tags. In the code snippet, we define a test named User Authentication, which is critical to our application. By using tags such as login, critical, and release v12, we can easily group and identify the purpose of this particular test. This strategic approach to tagging enables us to quickly filter and locate related tests, ensuring that our testing efforts are organized and can be aligned with specific releases or milestones. For example, tagging tests with release v12 allows the team to focus on what was tested for that specific version, facilitating smoother discussions and evaluations during release planning. Implementing these tags not only aids in test management, but also promotes collaboration among team members by making the testing landscape more understandable. With well-categorized tests, each team member, including developers, QA engineers, and product managers, can stay informed about the testing progress and focus on critical functionalities without needing in-depth technical knowledge. This clarity ultimately drives better decision-making as features evolve and are released to users. Now let's implement the following configuration to set up Slack notifications for our test results within our CI/CD pipeline. This code snippet is crucial for keeping your team informed about the status of your test runs, particularly when failures occur. First, we define a step in the workflow specifically for notifying Slack about test results. The if failure condition ensures that this step only triggers if the previous test execution fails, thereby preventing unnecessary notifications when tests pass. By using the 8398A7 action Slack at v3 action, we leverage a predefined GitHub action that simplifies sending messages to Slack. The with section allows us to customize the notification. We're passing the job status using job status, which dynamically reflects whether the tests passed or failed. Additionally, the field's parameter can be utilized to include contextual information, giving the team necessary details at a glance. Finally, the webhook URL is sourced securely from our repository secrets, ensuring that sensitive information remains protected. This integration not only keeps everyone in sync, but also facilitates instant communication, allowing your team to respond quickly to any issues detected during testing. Continuing with the benefits, let's talk about improved test management through the Cypress dashboard. As projects grow, maintaining a suite of tests can become cumbersome. The dashboard simplifies the process of organizing and managing these tests, providing an overview of the entire testing suite's health. When you group tests, you can see which areas are well covered and which could use additional testing. If your dashboard shows a low number of tests for critical functionalities, that is an immediate point of action for your team. Expanding your test coverage ensures that your application remains robust as development progresses. Furthermore, the ability to run tests selectively is another powerful feature. You might want to rerun only failed tests or execute specific groups. This flexibility can save time and resources, allowing your team to focus on what matters most at any point in the development lifecycle. Now let's see how we can define environment variables within our Cypress configuration file to securely manage sensitive information during testing. In the provided code snippet, we are specifying an env object within the JSON configuration. Here we define two key variables, API URL and Cypress record key. The API URL points to the location of the API your tests will interact with, ensuring that all test scripts reference this centralized endpoint, thereby eliminating hard-coded URLs directly within the tests. This not only enhances maintainability, but also allows for environment-specific configurations. The Cypress record key serves as a key for recording test results in the Cypress dashboard. By storing this key as an environment variable, you protect sensitive credentials from exposure in your source code, which is especially important in collaborative environments like CI/CD pipelines. By utilizing this approach, you ensure that sensitive data remains secure while also facilitating smooth test execution across different environments without compromising privacy or security practices. In conclusion, the benefits of using the Cypress dashboard are vast and create a holistic atmosphere that enhances testing quality and collaboration within teams. By leveraging real-time visibility, powerful analytics, flakiness management, collaboration tools, improved test management, and robust security controls, teams are better equipped to deliver high-quality software releases. So as you integrate the Cypress dashboard into your testing workflow, consider how these features can actively reduce debugging time, improve team alignment, and most importantly, ensure your application remains stable as it evolves. By doing so, you will not only enhance efficiency, but also embrace a testing culture that valued transparency and high standards. Now it's time to implement these strategies and see how your testing process can transform with the insights and functionalities the Cypress dashboard provides. Thank you for tuning in, and I hope you enjoyed our exploration of the Cypress dashboard benefits. Sure, here's an engaging YouTube-style video script on the integration of CI/CD into existing projects with a focus on using Cypress. The advent of continuous integration, CI, and continuous deployment, CD, has revolutionized the way we deliver software. In this lesson, we'll explore how to integrate CI/CD into existing projects seamlessly. So far, we've learned about integrating Cypress with CI/CD pipelines, including aspects such as testing configuration and managing sensitive data. Now let's dive into the integration process and make those existing projects CI/CD ready. Now let's take a look at how to clone the Volt React dashboard repository and examine its key components. The first line of code uses the git command git clone, which allows us to create a local copy of the repository from GitHub. This command pulls the entire codebase to your machine, making it accessible for further development and exploration. It's a fundamental step that sets the stage for understanding the project structure and dependencies. Next, we turn our attention to the package JSON file, focusing on the scripts section. Here we define several crucial commands that drive the project's functionality: start, build, test, and deploy. The start command initializes the development server, allowing you to serve the application locally. The build command compiles the source code for production, optimizing it for deployment. The test command runs the project's test suite, ensuring that your code behaves as expected. Finally, the deploy command utilizes the GH-Pages package to publish the built application to GitHub Pages, making it accessible online. Understanding these scripts is vital for successfully integrating CI/CD into the project, as they dictate the commands used in the CI/CD pipeline. Next, we'll ensure that the application is set up correctly by installing the necessary dependencies. To do this, you simply need to run the command to install packages specified in the package.json file. This step is crucial as it pulls in all the libraries and dependencies your project needs to function seamlessly. Once the installation completes, it's time to verify that everything is working as expected. Now let's execute the command to start the application, which will launch it on your local server at the specified address. When you run this command, you should see your application appearing in your web browser at http://localhost 3000/. This stage is essential because it confirms that your environment is correctly configured before proceeding to integrate CI/CD workflows. If you encounter any issues during this step, it's important to troubleshoot them to ensure a smooth transition into the CI/CD pipeline setup. With everything running smoothly locally, you'll be ready to dive into the next exciting phase of adding continuous integration and continuous deployment capabilities to your project. Now let's implement the continuous integration (CI) pipeline using GitHub Actions. The YAML configuration begins by defining the name of the workflow and specifying the events that trigger it, such as code pushes and manual dispatches. This setup ensures that anytime you push new code, the CI process kicks into action. Next, we define a job named CI that will run on a self-hosted runner. The steps within this job begin with checking out the repository's code, allowing the pipeline to access the latest changes. Following this, we set up the Node.js environment, specifying the desired version, which is crucial for running our application consistently with the same dependencies. The next step involves installing the project dependencies using npm, ensuring all necessary packages are available for the application to function correctly. Finally, we run the tests defined in the project, providing a safeguard that ensures any new code does not break existing functionality. This streamlined CI configuration serves as the backbone of maintaining code integrity every time changes are pushed, promoting a culture of continuous validation in your development workflow. Now let's implement a more segmented approach to our CI pipeline by breaking it down into two distinct jobs: install and test. This separation enhances clarity and control over our workflow, allowing us to manage the success or failure of each step independently. First, the install job is executed, which runs on a self-hosted runner. It starts by checking out the code from the repository, then sets up the Node.js environment with a specified version. Following that, it runs the command to install all necessary dependencies. This structure ensures that everything needed for the subsequent testing is in place before moving forward. Once the install job completes successfully, we can then proceed to the test job. This job also operates on a self-hosted runner and is dependent on the successful completion of the install job due to the needs keyword. It again checks out the latest code, but this time its primary focus is to execute the test suite. By organizing our CI pipeline this way, we improve the management of each stage's execution and make debugging failures simpler, as each job can be inspected individually if issues arise. Now let's implement the continuous delivery CD pipeline using GitHub Actions. We start by creating a new YAML file named cd-iml within the GitHub/workflows directory. This file is structured to initiate a deployment process for your application when you're prepared to publish a new release. The pipeline is triggered manually with on workflow dispatch, allowing you to control when deployments occur. Within the jobs section, we define a single job called CD, which runs in a self-hosted environment. The first step is to set up the node environment using the action setup node at v2 action, specifying Node.js version 14 to ensure compatibility with your project's dependencies. Next, we take a crucial step in the deployment process by configuring the Git remote URL to include your GitHub token, which securely authenticates the deployment. This approach uses the GitHub token stored in your repository's secrets to maintain security during the operation. Finally, we execute the deployment command npm run deploy, which pushes your newly built application to GitHub pages, making it publicly accessible for your users. This streamlined setup allows for efficient and secure releases, ensuring your application is always up to date. After you've constructed both CI and CD pipelines, it's essential to monitor their performance and maybe iterate over time. You can start by reviewing your GitHub Actions logs for errors or warnings. Use your CI/CD pipeline as a living document. Keep refining and enhancing it as you incorporate new features into your project. Integrating CI/CD into existing projects may seem daunting at first glance, but the beauty lies in its simplicity. With just a few lines of code and a couple of YAML files, you can have robust integration and delivery pipelines running in no time, even in projects that previously had none. And remember, deploying updates frequently and reliably can and should lead you towards greater efficiency as a developer. Projects like Cypress that support this process will save you time and effort. So get out there, integrate CI/CD into your projects, and watch productivity soar. By now, you should have the confidence to integrate CI/CD into any existing project you encounter, ensuring that testing and deployment processes are as smooth as they are crucial. Next up, we'll cover working collaboratively on tests. Now let's implement the command to clone the Volt React dashboard repository to our local machine. By executing the command git clone https://github.com/themisberg/voltreact dashboard git, we pull the entire repository, which includes all project files and folders, right into our development environment. This step is crucial as it serves as our starting point for further development and exploration of the project. Once we have the repository on our local machine, we'll navigate into the newly cloned directory using cd voltreact dashboard. This command changes our current working directory to the project folder, allowing us to easily access and manage project files. Understanding how to maneuver between these directories is key, as it sets the stage for executing other commands and working with the project structure. From here, we can begin exploring the various files, such as the package, JSON, which outlines the dependencies and scripts necessary for our development. Now let's take a look at the scripts section of the package, JSON file, as it's pivotal for managing our project workflows. This section outlines various commands that we can execute to interact with our application efficiently. First, the start command initiates a local development server using React scripts, allowing us to preview our changes in real time as we develop the application. This immediate feedback loop is invaluable for iterative development. Next, the build command compiles our React application into a production-ready bundle, optimizing performance and ensuring everything is configured correctly for deployment. Additionally, the test command runs our test suite using React scripts. Although we might not have automated tests yet, it's designed to manage testing efficiently when we implement them in the future. Lastly, the deploy command uses the GH-Pages package to deploy our application to GitHub Pages directly, making it accessible online. Understanding this configuration enhances our ability to build, test, and deploy effectively, setting the stage for continuous integration and deployment integration later on. Now let's see how we can get our development environment ready by installing all required dependencies. We begin by running the command that fetches all packages specified in the package, JSON file, ensuring our project has everything needed to run smoothly. Occasionally, you might encounter errors during this step due to missing packages or version conflicts, and if that happens, don't worry. Be sure to check the terminal error messages as they provide valuable insights. Once the dependencies are installed successfully, we can proceed to build our project. The next command compiles the application and prepares it for production by bundling everything into an optimized build folder. This is a crucial step as it enhances the performance of our app when deployed. After building the application, we'll want to see it in action locally. This is where we run the command to start a development server which hosts our application, allowing us to view it in our web browser at http://localhost 3000. This live preview is essential for testing our application and ensuring that everything functions as intended before we go any further. Now let's see how we can verify our application and prepare it for deployment. First, we need to ensure that our code is functioning correctly by running tests. We can do this by executing the command to run tests, which will help us confirm that everything is working as intended, even if we don't have automated tests set up yet. Running this command will indicate that there are no tests defined at the moment, and that's completely fine as we are still in the early stages of development. Next, we will implement the command that prepares our application for deployment. This command utilizes the GH-Pages package, which allows us to publish our application to GitHub Pages with ease. By executing this command, we ensure that our app is optimized and ready to be shared with the world whenever we decide to go live. This step is often missed, but is critical to ensure our project is accessible to users, marking an important part of our deployment process. Each of these commands is essential for validating our work and taking the next important steps in developing and deploying our application. Now let's take a look at how to implement our continuous integration (CI) workflow using GitHub Actions. We start by defining the workflow name as CI, which will help us identify it later. This workflow is designed to trigger on any push to the main branch of our repository or can be manually triggered via the workflow dispatch option. Next, we specify the jobs that will run as part of this workflow. In this case, we define a single job called CI that will execute on the latest version of Ubuntu. Within this job, we detail the necessary steps to ensure our code is prepared for testing. First, we use the checkout action to pull the latest code from the repository, which is essential for running our tests against the most current version of the application. Following that, we set up Node.js to ensure that our environment matches what our application requires. The Node version is specified, enabling us to install the necessary dependencies using the npm install command. Finally, we execute the tests with the npm run test command, which will validate that our application is functioning as expected. By implementing this CI workflow, we establish a robust foundation for automated testing and quality assurance before deploying any code changes. Next, we will implement the continuous deployment CD pipeline for our Vault React dashboard using GitHub Actions. We'll create a new YAML file named cd.iml in the GitHub/workflows directory, where we define the deployment workflow. This configuration allows the workflow to be manually triggered, enabling you to deploy your application when you're ready. The job runs on the Ubuntu environment, ensuring a consistent setup for deployment. Initially, we use the Actions checkout action to pull down the latest version of our code from the repository. Following this, we set up Node.js specifying version 14, which is critical since our application depends on this environment for building and running successfully. The main focus of this deployment step is the execution of the deploy to GitHub pages action. Here, we first run the build command to compile our application. After building, we use the git remote set URL command, which ensures that we are pushing our changes to the correct repository using a secure token stored in GitHub secrets. Finally, we execute the deployment command, which utilizes the ghpages package to publish the built application. This structured approach automates the deployment process efficiently, making it streamlined and reliable. Now that we have both CI and CD workflows set up, monitoring and refining these processes is paramount as you continue to develop your application. With every push that you make, the CI workflow will run tests and ensure the integrity of your codebase. When you want to deploy, simply trigger the CD workflow, and it will automatically publish your app live. In summary, by cloning the Vault React dashboard repository, installing necessary dependencies, understanding the project structure, and setting up CI/CD workflows, we've laid the groundwork for efficient development, testing, and deployment practices. Now, your Vault React dashboard is not just a static project. It's equipped with modern tooling to help you manage your workflow better and bring new features to users quicker. In conclusion, the journey of setting up the Vault React dashboard doesn't just stop at seeing it live. It opens the doors to so many possibilities. Now that everything is well established, you can focus on building exciting features, enhancing user experiences, and improving the architecture. Keep exploring, experimenting, and pushing boundaries within your application. Now let's take a look at the package.json file we've configured for our Angular real-world example app. This file is crucial because it acts as a manifest for the project, defining its basic settings while listing all dependencies needed to run the application effectively. Within the scripts section, we can see essential commands related to Angular CLI that facilitate various tasks. For instance, the ngserve command starts the development server, allowing us to observe changes in real time as we work on the app. The ngbuild command is vital for creating an optimized output of our application, ready for deployment. Additionally, the ngtest script allows us to execute unit tests, ensuring our components behave as expected, while ngETui is used for running end-to-end tests to validate the entire application flow. This systematic approach allows for seamless integration into our CI/CD pipeline, making it easy to automate building, testing, and deploying processes. With our package.json structured this way, we set a solid foundation for efficient project management and workflow automation in our development environment. Now let's implement our CI workflow to automate testing and ensure code quality with GitHub Actions. We begin by defining our YAML configuration file named cy.iml, placed in the GitHub/workflows directory. This file specifies actions that will trigger on push events or pull requests directed to the main branch, allowing us to catch issues early in the development process. First, we set up our job to run on the Ubuntu latest environment. The steps begin with checking out the latest code from our repository using the checkout action, ensuring that we are working with the most recent commits. Next, we configure our Node.js environment with the setup node action, specifying the version as 14, which is essential for running our Angular application correctly. Following that, we perform dependency installation by executing the npm install command, which pulls in all necessary packages outlined in our package.json. Finally, we run our test suite with npm test. This step is crucial as it validates the functionality of our code to guarantee that any pushed changes meet our quality standards before they can be merged into the main branch. If all tests pass, we can confidently move forward with our development. Now let's implement the continuous deployment workflow by creating a cd.iml file. This configuration is specifically designed to trigger on any push to the main branch, allowing us to seamlessly deploy our Angular application when updates are made. First, we utilize GitHub Actions to check out the code from the repository, ensuring we work with the latest version. Next, it's crucial to set up Node.js, which is the runtime environment for our application. We'll specify the version of Node.js to ensure compatibility with our project dependencies. After that, we execute the npm install command to install all required packages listed in our package.json, facilitating a smooth build process. Now we'll build the application using the npm run build command, which compiles the source code into optimized bundles stored in the dist directory. This is a pivotal step as it prepares our application for deployment. Finally, we address the deployment process, where we'll globally install the Azure CLI and use it to deploy our application to Azure Web Apps. It's vital to customize the placeholders for the resource group and app name with your actual Azure information. This setup illustrates a complete flow from code update to deployment, automating our continuous delivery process effectively. Next, we will write a simple counter component that keeps track of increments. The code begins by importing the necessary component decorator from Angular. We use this decorator to define a new Angular component, specifying a selector app counter that will be used in our templates. The component's template includes a simple HTML structure featuring a heading that displays the current counter value and a button that triggers an increase in this value when clicked. The component class contains a single property, counter, initialized to 0. This property holds the current count and will update each time the button is pressed. We define an increase method which increases the counter by 1, allowing us to see how changes in component state are reflected in the UI. This straightforward implementation demonstrates the basics of Angular component interaction, where user actions directly result in changes to the displayed data. Now that we've created our counter component, it's essential to write tests to ensure its functionality. Let's see how we can implement the test suite for this component to verify that it initializes correctly and that the button click successfully increments the counter. Now let's implement a linting script in our package.json to ensure code quality throughout our development process. Within the script section, we can add a new entry for linting by specifying lint ng-lint. This command utilizes Angular's built-in linting capabilities, allowing us to check our code against defined coding standards and conventions. Next, we can integrate this linting step into our CI/CD pipeline. In the GitHub Actions workflow configuration, we will define a new step named lint the code, which will run the command npm run lint. By incorporating this step into our continuous integration process, any code that fails to comply with our linting rules will cause the CI pipeline to fail. This prevents non-compliant code from being merged into the main branch, effectively promoting adherence to coding standards within our team. By automating linting in our CI/CD workflow, we create a more efficient feedback loop, encouraging better coding practices and ultimately resulting in a cleaner, more maintainable code base. As we progress in developing our Angular application, we should be aware of some best practices for managing CI/CD workflows. One best practice is to always keep your CI/CD configurations in version control, just like your main application code. We also recommend organizing your workflows logically so that they're easy for team members to understand. Additionally, keeping your pipeline fast is crucial. Long pipelines may discourage developers from writing tests or linting code if they increase feedback times. To keep them efficient, consider breaking down large processes into several smaller workflows that can run in parallel when possible. Making use of caching in your CI/CD pipelines can also significantly reduce build times for dependencies that haven't changed. In conclusion, mastering the Angular real-world example app workflow through effective usage of CI/CD processes allows us to enhance development practices significantly. We covered the importance of the package, JSON, file, and explored the powerful scripts that it holds. By setting up CI/CD with GitHub Actions, we can automate our testing and deployment processes. We dove into writing unit tests, ensuring our code remains consistent, and effective linting practices, all integrated into our automated workflows. As you continue to develop your Angular projects, incorporating these practices will not only improve the quality of your applications, but also foster a more collaborative and efficient team environment. Keep exploring, experimenting, and don't forget, robust automation is your best friend in modern software development. The Agile methodology emphasizes the importance of integrating testing throughout the software development process. Unlike traditional methods where testing is often a separate phase after development, Agile encourages teams to consider testing as an integral part of each sprint. This approach leads to a more collaborative and dynamic workflow, allowing teams to deliver high-quality products efficiently and effectively. So far, we learned about the Angular real-world example app workflow, focusing on managing projects with CI/CD practices. We explored setting up the development environment, utilizing the package, JSON file, and configuring CI/CD pipelines through GitHub Actions for automated building, testing, and deployment. Additionally, we discussed the importance of unit testing and linting to ensure code quality as part of our workflow. With these foundational concepts, we are equipped to enhance our application and improve our development processes. Now, we will talk about the vital integration of testing in Agile methodology and how it enhances the overall software development process. In Agile, testing begins early in the development cycle, which significantly reduces the chances of discovering critical bugs late in the process. The Agile approach promotes a philosophy known as shift-left testing. In this strategy, testing is prioritized before the actual coding begins. For instance, when using a test-driven development (TDD) approach, developers write tests first and then implement code that fulfills those tests. This paradigm shift allows teams to catch issues sooner and continually validate that the code meets the acceptance criteria. Now let's examine a simple test case written in Cypress that evaluates the login component's error handling. This test is structured within a described block, which organizes our test suite by grouping related tests together, in this case, tests pertaining to the login component. Within this suite, the IT block outlines an individual test that checks whether an appropriate error message is displayed when invalid credentials are entered. First, the test navigates to the login page using the visit command, simulating a user accessing that URL. Next, we use get to select the username and password input fields, where invalid credentials are entered to mimic a user inputting the wrong data. Following the input, the test clicks the submit button to trigger the login process. Finally, it examines the page for an error message, asserting its visibility and ensuring it contains the specific text, invalid credentials. This approach not only validates the expected behavior of the login component, but also reinforces the importance of writing tests before the functionality is fully developed, enabling developers to create code that meets predefined success criteria. Now let's take a look at how we can implement a test case for adding an item to a shopping cart in an e-commerce application using Cypress. This code follows the principles of the shift-left testing approach, where we begin with tests before actual code development. In this test case, we describe a suite called Shopping Cart, which groups related test scenarios. Within this suite, we define a specific test using the IT function, indicating that we are checking if an item can be successfully added to the cart. The first step in our test is to visit the shop page where the items are displayed. This is done with the visit/shop command, which opens the specified URL. Next, we simulate a user action by selecting the first item on the page with get item first click. This command captures user interaction by clicking on the item to be added. After making the selection, we proceed to click the Add to Cart button using get Add to Cart button click. Finally, we verify the result by checking if the cart now contains one item with the command get cart should contain one item. This assertion ensures that our Add to Cart functionality works as expected, reinforcing the importance of early testing in the Agile development process. Another key advantage of integrating testing into Agile is the quick feedback it provides. Frequent testing during sprints allows developers to understand the impact of their changes almost immediately. If a test fails, the team is alerted right away, minimizing the amount of rework needed down the road. This rapid feedback loop boosts team morale and keeps everyone aligned toward the same goals. Consider the case where the development team implements a new feature but inadvertently breaks an existing functionality. The Cypress test runner continuously executes tests, and when the regression occurs, the test suite highlights the failure immediately. This prevents shipping a broken product and penalizing end users with bugs. Next, we will write a line of code using Cypress to enhance our testing capabilities for form input validation. The command get input name equals email, type user at example com, debug, demonstrates how to target an email input field in a login form. Here get input name equals email is used to select the input element with the name attribute set to email, ensuring that we interact with the correct part of the DOM. The type user at example com method simulates user input by entering the email address into the selected field, which is essential for testing scenarios where user data is expected. To aid in debugging, the debug command follows the input method. This feature pauses the test and logs the current state of the command chain in the developer console, which allows developers to inspect any potential issues during test execution. By using this command, you can analyze the precise status of your test and validate what is happening at that moment, thus enhancing our ability to identify and resolve flaky tests that may arise due to environmental inconsistencies or other issues. Furthermore, utilizing the Cypress dashboard can eliminate some of the common uncertainties that come with flaky tests. By visualizing test runs and failures, teams can use the insights provided to address instability and fix underlying issues. It's about building confidence in the automated tests they have in place. One best practice to remedy flakiness is to standardize testing environments. This can be achieved through Docker, ensuring that every developer and CI/CD pipeline runs against the same base setup. Keeping everything in sync allows for better consistency across test outcomes. Now let's take a look at how we can establish effective contributing guidelines for our project. These guidelines serve as a foundational element for maintaining code quality and accountability within the team. To start, we emphasize the importance of writing tests before submitting any pull requests. This practice ensures that any new features or bug fixes are adequately covered, allowing for immediate validation of the changes made. Next, we stress the necessity of running all existing tests to confirm that they pass, ensuring that previous functionality remains intact while incorporating new code. This step is crucial for preventing regressions, which are unintended bugs that can arise when adding new features. Finally, we encourage peer reviews of the test cases. By reviewing each other's work, team members can collectively assess the comprehensiveness of the tests, which fosters a shared sense of responsibility towards quality assurance. This collaborative approach enhances the overall quality of testing and helps align the team's understanding and expectations. By implementing these guidelines, we cultivate a culture of excellence that drives continuous improvement in our development practices. Ultimately, the integration of testing into Agile methodology isn't merely a technical requirement. It's a vital aspect of modern software development that enhances collaboration, ensures quality, and provides quicker release cycles. This approach not only meets user requirements more effectively, but also fosters a culture of quality-first thinking among developers. As we move on from here, remember that testing is not an isolated field, but one that interweaves seamlessly into your coding practices. Each piece of code written needs to be validated against expectations to maximize quality and functionality. Embrace the Agile principles, prioritize testing early, and witness the transformation in your product's quality and delivery timelines. Let's continue our journey in mastering testing frameworks and methodologies that empower us to build better software. When adopting the shift-left testing (SLT) approach, the tests are written in the early stages of the development cycle. This proactive strategy transforms the way developers integrate testing into their workflow. Today, we will delve into the intricacies of SLT and its impact on quality assurance in software development. So far, we learned about the integration of testing in Agile methodology, emphasizing its importance throughout the software development process. We explored the shift-left testing philosophy, which prioritizes testing before coding to catch issues early. This approach fosters a culture of quality, with developers writing tests for new features and ensuring rapid feedback through continuous testing. Overall, effective testing practices enhance collaboration, improve product quality, and streamline release cycles. Now, we will talk about the shift-left testing approach and how it ensures high-quality software development from the moment the first line of code is written. Let's kick things off by understanding what shift-left testing really means. In traditional development approaches, testing often occurs at the end of the development cycle, which can lead to late discoveries of bugs and issues that affect the project timeline and budget. By shifting testing left, we ensure that quality is considered and validated at each step of the development process rather than just at the finish line. It's akin to catching a cold early with some vitamin C rather than waiting until you're bedridden. The earlier you intervene, the better. For context, in an Agile environment, the SLT approach encourages collaboration among developers, testers, and stakeholders right from the start. Developers are prompted to think about their tests as soon as they begin writing code. This shift in mindset not only helps to identify potential issues early, but also fosters a culture of ownership and accountability among team members. Ultimately, proactive testing leads to better product quality and a more efficient development cycle. Next, we will write the following test for our comment feature using Cypress, a popular tool for end-to-end testing. The code begins with a describe block which groups related tests together under common name, in this case, comment feature. Inside this block, we define an individual test using the it function, explaining what the test should accomplish, specifically that it should allow a user to submit a comment. Now let's implement the steps involved in this test. The first action is to navigate to a specific blog post using visit, which simulates the user visiting the page where they can submit their comment. Following this, the test uses get to find the text area where users input their comments and types a predefined comment. This is a test comment into that text area. Next, it simulates the user clicking the submit button to add the comment. Finally, we use another get command to check whether the comment appears in the comments list by asserting that it contains our test comment. This assertion ensures that if the feature does not work as expected, feedback is immediate, allowing developers to resolve any implementation issues right away. This proactive approach solidifies the essence of shift-left testing, as developers validate expected outcomes early in the development process. Now let's see how we can implement a CI/CD pipeline using GitHub Actions to automate testing with every code change. This YAML configuration sets up a continuous integration workflow that triggers whenever code is pushed to the main branch of the repository. The workflow begins with a job named test that runs on the latest version of Ubuntu to ensure a stable environment for execution. The first step is to check out the code using the Actions checkout action, which allows the workflow to access the latest version of the source code. Following that, we install the necessary dependencies using npm. This step ensures that any packages required for the code to run are available. Finally, we run the tests by invoking the npm test command. This is where the magic happens. It executes all the test cases defined in your project, providing immediate feedback on whether the latest changes introduced any issues. This setup not only promotes a rapid development cycle, but also aligns perfectly with the shift-left testing approach, enabling teams to identify and address potential problems early in the development process. Now let's see how we can implement a simple function to count the total number of comments in a blog post. We begin by defining the count comments function, which takes an array of comments as an argument. The core functionality here is straightforward. It simply returns the length of the comments array. This effectively gives us the total number of comments submitted. Next, to ensure our function behaves as expected, we will write a unit test using Cypress. This test will be encapsulated within a describe block titled comment count, which serves to group related tests. Inside this block, we specify an individual test case using the it method, stating that it should return the total number of comments. We will create an array called comments, populated with sample strings representing user comments. The count comments function is then called with this array, and we assign its result to a variable named result. Finally, we utilize the expect assertion to verify that the output matches our expectation, for this specific case, that it equals 3. This structured approach to function and test definition not only ensures correct functionality, but reinforces the shift-left testing philosophy by focusing on requirements from the outset. A key advantage of SLT is that it nurtures a rapid feedback loop among the whole team. Developers can resolve issues early before they become larger problems, creating a smoother workflow. Standardizing testing practices ensures everyone is on the same page, fostering collaboration and minimizing silos between roles. In practice, this might mean holding regular stand-ups to discuss tests and any issues encountered. Everyone from product owners to developers engages in quality conversations. Tests become a team responsibility rather than solely a testing team's job. However, with great power comes great responsibility. Shift-left testing also brings its challenges. As dependencies among various components grow, tests may become more complex and time-consuming to maintain. This necessitates the need for a well-structured test plan to avoid flaky tests, which can sabotage the rapid feedback loop we aim for. Now let's take a look at how we can enhance our comment submission test with logging features. This test begins by visiting a specific blog post URL, where it simulates a user typing a comment into a designated text area. Following that, the test clicks the Submit button to send the comment. Once the comment has been submitted, the test asserts that the comments list should contain the newly added comment, ensuring that the submission was successful. However, to improve our debugging capabilities, we introduce a logging mechanism. If the test fails to find the comment in the comments list, a helpful log message is displayed, indicating that comment submission has failed due to the absence of the comment. This logging feature is critical because it provides immediate feedback on what went wrong during the test, thus allowing developers to swiftly address any issues. By implementing such detailed logging, we not only enhance the test's reliability, but also streamline the troubleshooting process, thereby facilitating a smoother development lifecycle. Attention to these details can make a significant difference in identifying and resolving problems efficiently. As we wrap up our examination of the shift-left testing approach, remember that its core philosophy of proactive quality assurance is fundamental in today's fast-paced development environments. It allows for seamless collaboration, expedites issue resolution, and fosters a culture of shared accountability among team members. Adopting SLT not only allows developers to deliver higher quality software faster, but it also cultivates a work environment where quality is seen as everyone's responsibility rather than an afterthought. Testing becomes part of the development rhythm rather than a separate phase, positioning teams to be proactive rather than reactive. So as you step into your next development endeavor, think about how you can integrate shift-left testing into your workflow. It's not just about writing good code, it's about writing good code that works and meets user expectations from the very beginning. Together, let's build software that's not only functional but of high quality, ensuring a better experience for everyone involved, from developers to end users. When a team decides to adopt a serious approach to testing, by implementing the shift-left testing strategy and following test-driven development principles, it's imperative that the team aligns on a series of effective test management practices. In this lesson, we'll explore practical tips for effective test management, ensuring that your testing efforts contribute to high-quality software and streamlined development processes. So far, we learned about the shift-left testing approach, which integrates testing early in the software development process to catch issues before they escalate. This method emphasizes proactive collaboration among team members, establishing clear expectations and ownership from the outset. By implementing tests alongside code, teams enhance product quality and efficiency through rapid feedback mechanisms. Overall, SLT fosters a culture of shared responsibility for quality throughout the development lifecycle. Now we will cover practical tips for effective test management that can enhance your development workflow and improve software quality. To kickstart effective test management, it's vital to establish clear objectives for testing. By figuring out what you aim to achieve through testing, you create a coherent strategy that guides your efforts. Start by defining your success criteria. This could involve catching a percentage of defects in a specific time frame or ensuring that all critical features have a certain level of test coverage. Once you've established your objectives, communicate these to the entire team. This transparency helps everyone understand the expectations surrounding testing and motivates them to strive toward those goals. For example, imagine a simple testing goal. We want to achieve at least 80% code coverage for our new user authentication feature within the next sprint. Setting a clear target like this aligns the team and drives collective ownership of quality. By having such quantifiable metrics, you not only gauge success but also promote accountability. Now let's see how we can implement a basic test for user authentication using Cypress. This test suite is structured using the describe function, which helps us group related tests for better organization and readability. Inside this suite, we have a single test case defined with the it function, which outlines the specific functionality we want to verify in this case, allowing a user to log in with valid credentials. Next, we commence the test by directing Cypress to the login page using the visit command. Once on the page, we simulate user interactions by targeting the email and password input fields. The get command retrieves these elements based on their attributes, and we use the type method to input the user's credentials. After filling out the form, we initiate the login by clicking the submit button with get followed by click. To ensure that the authentication is successful, we check if the application's URL contains dashboard, indicating the user has been redirected to their dashboard. Finally, we verify that a welcome message is displayed on the screen, confirming that the login was successful. This structure not only checks for expected outcomes, but also demonstrates how Cypress can be used to automate assertions effectively. Now let's implement the following tests to ensure our transaction feature works as expected. We start by utilizing the describe function to group related tests under the transaction feature suite, which helps in organizing our tests and improves readability. The first test case checks whether a transaction can be processed successfully with valid input data. Here, we simulate a user navigating to the transaction page, entering an amount and recipient, and submitting the form. After clicking the Submit button, we assert that the success message appears, indicating a successful transaction. Next, we need to account for scenarios where the transaction might fail. The second test case handles an edge case by inputting an amount that exceeds the user's account balance. We again simulate the user's actions of visiting the page, entering the excessive amount, and attempting to submit the transaction. In this case, we check that an appropriate error message is displayed, informing the user about insufficient funds. These tests not only verify the basic functionality, but also ensure that critical edge cases are addressed, demonstrating our focus on quality and risk management in testing. Now let's take a look at how we can automate our Cypress testing process using GitHub Actions. This YAML configuration defines a continuous integration (CI) pipeline that triggers automatically when code is pushed to the main branch of your repository. First, under the Jobs section, we're specifying a job named Test that runs on the Ubuntu latest operating system, which is commonly used for CI tasks. The steps outlined in this job begin with checking out the code using the Actions checkout at v2 action. This step ensures that the workflow has access to the code in the repository for testing. Next, we install the necessary dependencies by using the command npm-ci, which installs packages based on the version specified in the package lock JSON file, ensuring consistency across environments. Finally, we run our Cypress tests with the command npm run cypress run, which executes the tests defined in our Cypress test suite. By implementing this CI pipeline, we ensure that code changes are automatically tested, thereby maintaining code integrity and confidence in the application as it evolves. Now let's take a look at how we can structure our Cypress tests to ensure they are well organized and easy to maintain. In this approach, we create distinct directories for different functionalities within our application, allowing for clarity and simplicity when navigating through the test files. For instance, under main directory like Cypress integration, we can have subfolders such as products and users. Inside the products folder, we place test files like add product spec.js and remove product spec.js, each dedicated to testing specific features related to product management. Similarly, the users folder can contain files such as login spec.js and registration spec.js, which focus on user authentication and registration processes, respectively. This logical grouping of tests not only makes it easier for team members to locate relevant tests, but also streamlines collaboration by ensuring that related tests are kept together. Additionally, it's essential to remember to comment on the tests where necessary, as this provides context and helps future developers quickly understand the intent behind each test case. By implementing this organized structure, we enhance the maintainability and clarity of our testing efforts in Cypress. Next, as your application evolves, keeping an eye on the test results and analyzing failures is critical. Effective test management goes hand in hand with continuous monitoring and consideration of test performance. When tests fail, delve into why. Is it a legitimate bug or is the test flawed? By analyzing trends in test failures, you can identify frequent areas of concern, which can guide future development and testing efforts. For example, if you notice a specific component such as the user profile update tests failing repeatedly, it might indicate that recent changes are affecting this feature. You can narrow down the changes and fix the underlying issue promptly. Capturing this data and discussing it with the team can lead to more robust coding and testing practices. Furthermore, cultivating a culture of quality assurance in your team cannot be overstressed. Shift-left testing not only encourages writing tests early, but also promotes collaboration among developers, testers, and even product owners. Involve everyone in discussions about testing goals and encourage the sharing of testing knowledge. A fun exercise might be to hold testing hackathons, where team members brainstorm together on unique test cases edge scenarios, or even mock review sessions to evaluate each other's tests. By fostering an environment where everyone feels responsible for quality, you can effectively reduce testing silos and improve overall application quality. As we wrap up our discussion on test management techniques, keep in mind that clear objectives, robust frameworks, careful prioritization, continuous testing, organized structures, failure analysis, and a strong team culture are the cornerstones of effective test management. Implementing these practices will not only enhance the quality of your software, but also streamline the development lifecycle, allowing your team to work more efficiently and collaboratively. In conclusion, don't forget that testing is not a destination, it's a journey. You'll continue to refine your processes as your application evolves and your team grows. So, embrace the shift-left testing approach and practice effective test management, and you'll set your teams up for success in delivering high-quality software that meets users' needs. The TDD approach is not new to software engineering, but it's crucial for developing reliable and maintainable software. Today, we are diving deep into test-driven development, or TDD. In this lesson, we will explore what TDD is, how it works, its advantages and disadvantages, and we'll even delve into a practical coding example using Cypress to make the concept come alive. So far, we learned about the importance of adopting shift-left testing and effective test management practices to enhance software quality. We discussed the need for clear objectives, implementing a robust testing framework like Cypress, and prioritizing tests based on risk and impact. Maintaining an organized test suite and continuously analyzing test results are crucial for identifying issues and improving testing efficiency. Finally, fostering a culture of quality assurance among team members can lead to more collaborative and effective testing efforts. Now we will cover what TDD entails, its process, and how we can apply it practically. Now let's take a look at how we can write a test for the multiply function using the Jasmine testing framework. We start by using the describe function to group our tests, clearly identifying that we're testing the multiply function. Within this group, we leverage the it function to specify a particular test case. In this case, the test is checking if multiplying the numbers 2 and 3 returns the expected result of 6. To implement the test, we require the multiply function from the module where it's defined. By applying the expect function, we can assert that calling multiply 2, 3 produces the correct output. This form of assertion fosters clarity, as it checks for equality between the actual output and the expected output. Importantly, since we have not yet defined the multiply function, this test is expected to fail initially, aligning perfectly with the red-green refactor cycle of TDD. This approach ensures we clearly define requirements up front, setting the stage for creating the function in the subsequent phases of TDD, where we will write minimal code to pass this test. Next, we will implement the multiply function, which is a straightforward yet essential piece of functionality in our example. This function takes two parameters, x and y, representing the numbers we want to multiply. Inside the function, we perform the multiplication operation using the asterisk symbol and return the result. By returning the product of these two numbers, we ensure that when we call the function with specific inputs, it provides the expected output. Moreover, to make our function accessible from other modules, we export it using module exports. This allows us to require the multiply function in our test files or other parts of our application, ensuring that the functionality can be reused across different components. As we proceed, the beauty of the TDD approach comes into play. Once we save this implementation and run our tests again, they should pass successfully. This confirms that our implementation meets the predefined requirements established during the testing phase, illustrating the core principle of TDD, building just enough functionality to satisfy the test criteria before moving on. Now let's implement the multiplication function with improved error handling. This function takes two parameters, x and y, which are expected to be numbers. To ensure that our function behaves correctly, we've added a check at the beginning to verify the type of each argument. If either x or y is not a number, the function throws an error with the message invalid input. This early validation step is crucial, as it prevents unexpected behavior and makes debugging easier by catching errors up front. Once we confirm that both inputs are valid numeric types, we proceed to return the product of x and y. This implementation not only performs the multiplication, but also provides a clear failure state if non-numeric inputs are provided, allowing us to create more robust tests. By ensuring our function adheres to defined behaviors, we make our codebase more reliable and easier to maintain. As we progress, we can continue to adjust and enhance this function, fully aligned with our test-driven development principles, thus ensuring that our tests will continue to pass under various scenarios. The benefits of TDD are numerous. For one, it improves code quality significantly and leads to a higher test coverage rate, often nearing 100%. Since you're writing tests first, you're also likely to be much more deliberate with your code architecture. The reliance on tests fosters confidence among team members, especially new developers joining the project. Knowing that there's a safety net of tests can ease the anxiety of code changes and refactoring. On the flip side, TDD does have its challenges. It can feel tedious and in some instances may seem counterintuitive, especially for developers new to it. There's a learning curve involved with TDD. Many developers are accustomed to writing their code first and then going back to add tests. It may also seem redundant to continually write tests for simple functionalities. Let's address how TDD can enhance workflow through code examples in Cypress, which is our primary focus in this course. Taking the previous examples, we can better apply such tests using Cypress to its full potential. Now let's implement the following Cypress test to validate our interactive multiplication feature. This test is structured within a describe block, which groups related tests together, in this case, focusing on the interactive multiplication functionality. Inside the it block, we define a specific test case that checks whether the application shows the correct result when two numbers are multiplied. To initiate the test, we start by visiting the application's URL using visit, which simulates a user navigating to the site. Next, we interact with the page by targeting the input fields where users will enter numbers. The get commands fetch the elements by their ID #input1 and input2, and the type method inputs the values of 2 and 3 into those fields. After the user inputs the numbers, we simulate a click on the multiply button through get combined with click. Finally, we validate the expected outcome by asserting that the result displayed matches our expectation, in this case, 6. This step is crucial as it confirms that the entire user interaction, from inputting numbers to receiving output, works properly. Another aspect to highlight is how TDD aligns cleanly with Agile methodologies. Agile champions iterative development, and TDD fits this paradigm perfectly by promoting constant feedback through testing executed as part of the development cycle. It naturally strives for quality while still meeting deadlines owing to its emphasis on writing only necessary code. To sum it up, today we explored test-driven development and how it integrates seamlessly with Cypress for creating robust and maintainable applications. You learned the fundamentals of TDD, its cycle of read, green, and refactor, and saw practical examples of how to implement and test features effectively. While TDD can feel repetitive or challenging at times, the long-term benefits it brings to website and software quality are undeniable. So remember, the TDD approach may seem daunting at first, but once you get into the rhythm of writing tests first, it becomes a powerful ally in your coding endeavors. Make it a habit, and you'll soon see your code quality and debugging capabilities skyrocket. In our next lesson, we will dive deeper into advanced testing strategies and discuss how Cypress can further enhance our TDD practice. In today's lesson, we're diving into a fascinating topic, Cypress-Driven Development, or CDD. This approach is particularly exciting because it's tailored specifically for the web development landscape, where browser interactions are at the heart of everything we build. So far, we covered test-driven development, TDD, exploring its essential processes and benefits that improve software reliability. Now, we will cover how Cypress can enhance our development practices by implementing Cypress-driven development to ensure our web applications function as expected through effective testing and automation strategies. Now let's see how we can implement a test suite for user login using Cypress. The code begins by defining a test suite using the describe function, which categorizes our tests under the title user login. Inside this suite, we declare an individual test case with the it function, describing the expected outcome, successfully logging in with valid credentials. In this test, we utilize several Cypress commands to simulate user behavior. We start with visit to navigate to the login page, setting the stage for our testing scenario. Next, we target the username and password input fields using get, where we employ the type method to programmatically enter the credentials for a test user. After filling in the information, we simulate clicking the login button with get, and click, mimicking a real user interaction. Following the attempted login, we verify that the user has been redirected to the dashboard using URL should, which confirms the URL includes dashboard. Finally, we incorporate an assertion with contains to check for a personalized greeting message on the dashboard, ensuring that the login process was successful and the application behaves as expected from the user's perspective. This comprehensive approach encapsulates real-world user interactions, demonstrating the power of Cypress in testing web applications. Now let's implement a login page class that will help us streamline our interaction with the login page by encapsulating all related actions. We begin by defining a class named login page, which provides methods to handle user interactions efficiently. The visit method directs the test to open the login page by using Cypress's visit command, ensuring that the correct route is accessed. Next, we have the fill username and fill password methods that take user input parameters for the username and password, respectively. These methods utilize get to locate the input fields and type to simulate user typing. This approach not only keeps our tests organized, but also makes it easy to reuse these methods across various test cases. The submit method completes the user interaction by targeting the submit button and triggering a click event. By having a dedicated class for our login interactions, we can easily manage any changes in the page structure by updating just the login page JS file. This refactoring enhances maintainability while promoting the use of best practices such as the page object model in testing. Now let's see how we can configure a GitHub action to automate the running of our Cypress tests every time code is pushed to our repository. The workflow begins with defining the name of the action and specifying that it will trigger on push events. This means every time changes are committed and pushed, the subsequent defined tasks will execute automatically. Next, we set up a job that runs on the latest version of Ubuntu, ensuring a consistent environment for our tests. Within the job, we outline the steps necessary for our workflow. The first step is to check out the repository code using a specific action, allowing the CI/CD pipeline to access the latest updates. Following that, we need to install our dependencies with a simple command, which ensures all required packages are available for Cypress to run smoothly. Finally, we include a command to execute our Cypress tests, leveraging npm to ensure our testing suite runs as intended. This setup for continuous integration not only enhances the reliability of our application, but also identifies potential issues early, making sure that every deployment is as stable as possible. By integrating these Cypress tests into our CI/CD pipeline, we create a robust testing ecosystem that supports ongoing development. Now let's implement visual testing for our application using Percy in conjunction with Cypress. First, we import Percy's essential Cypress integration with import at Percy/Cypress, which allows us to add visual snapshots to our tests seamlessly. Next, we define a new test suite titled Visual Testing Login Page, corresponding to our focus on ensuring a consistent user interface for the login page. Inside this suite, we create a test case that checks whether the visual representation of the login page matches our baseline snapshot. We begin by navigating to the login page using visit/login, simulating a user opening the application. Once the page is loaded, we employ Percy snapshot login page to capture a snapshot of the current UI state. This snapshot serves as a reference for future comparisons. When application updates occur, Percy will compare the new snapshots against this baseline image. If there are any visual discrepancies, Percy will flag them for review, allowing developers to easily identify unintended UI changes throughout the development process. This methodology enhances our testing strategy by ensuring visual consistency without the overhead of manual checks. Now let's see how we can implement a fixture in Cypress to streamline our test data management. First, we create a user JSON file in the Cypress fixtures directory, which holds our test credentials, specifically a username and password. This method centralizes our test data, making it easier to maintain and update without modifying the tests themselves. Next, within our test suite for the user login feature, we will load this fixture to access the data. We'll use the before each hook to ensure that our fixture data is loaded before each test runs. By calling fixture user as user data, we assign the loaded user data to the variable user data, making it accessible throughout our test. This approach not only improves the readability of our test code, but also enhances the reliability of our tests by relying on predefined data rather than real-time, potentially flaky data inputs. In the actual login test, we will access the username and password using this user data, allowing us to simulate the user input without hard-coding values directly in the test. This effectively shows how we can implement fixtures to enhance our Cypress tests by maintaining clean code and reducing the risk of errors in our testing processes. Finally, as we talk about Cypress-driven development, let's not forget the importance of collaboration within the team. Fostering a culture of mutual code reviews and shared responsibility for test coverage enhances application quality. Design sessions can encourage a collective approach towards defining what the user journey should feel like, ensuring everyone is on the same page. Encourage collaboration around your tests, whether through internal discussions, pull requests, or pairing sessions. This harmony in development builds a foundation of trust and teamwork that contributes to a more solid final product. As more people engage with writing tests and experimenting with Cypress, not only do you spread knowledge, but you also create a sense of ownership over the project results. To wrap up this section on Cypress-driven development, we've examined how this testing framework allows us to create robust applications through end-to-end testing in a browser context. By shifting our focus from traditional unit testing to simulating user behaviors, we open up new dimensions of QA for web applications. From embracing the page object model and integrating continuous testing within the CI/CD pipeline to utilizing visual regression testing and fostering teamwork, Cypress offers a plethora of tools to enhance our development process. With the right mindset, proper strategies, and useful tools at our disposal, we can take our web applications to new heights, ensuring they not only operate correctly, but also give users the seamless experiences they expect and deserve. Thank you for joining me in today's exploration of Cypress-driven development. In this lesson, we will delve into the advantages and disadvantages of Cypress-driven development, CDD, a powerful approach designed to streamline web application testing. By examining both the pros and cons, we can appreciate how it fits into the broader software development lifecycle. So far, we learned about CDD, which emphasizes testing real user interactions in the browser through end-to-end tests. We explored similarities to test-driven development, TDD, and discussed best practices like utilizing the page object model and continuous integration. Now, we will cover the benefits and challenges associated with implementing CDD in development workflows. Now let's see how we can implement a test for user login functionality using Cypress. In this code, we begin by defining a test suite called user login, which groups related test cases together. The suite contains a single test case that verifies successful login with valid credentials. Within the test case, we utilize the visit command to navigate to the login page. This simulates a user action of accessing the application. Following this, we use the get command to select the username and password input fields, where we simulate entering the credentials by using the type method to input John Doe and password 123, respectively. Next, we simulate clicking the submit button using get and click, which mimics the final step of the login process. Once the login attempt is made, we check that the URL has changed to include homepage, confirming that the user has been successfully redirected. We also assert that the page contains a greeting message, "Welcome, John Doe," ensuring that users not only access the homepage but also receive the correct feedback upon successful login. This comprehensive approach ensures the functionality works as intended, providing valuable assurance for the development team. Now let's take a look at how we can implement a test that verifies the login feature handles invalid credentials correctly. In this test, we begin by navigating to the login page using the visit command, ensuring that we are starting from the correct point in our application. After this, we simulate user input by targeting the username and password fields and entering incorrect values, wrong user and wrong password, which represent situations where a user attempts to log in with invalid data. Next, we engage with the login functionality by clicking the submit button. This action triggers the application to process the login request based on the credentials provided. To ensure that the application responds appropriately, we use the contains command to assert that an error message stating invalid username or password is displayed on the screen. This step is crucial as it checks not only that the application prevents the login, but also confirms the display of a user-friendly message, fulfilling the requirements of a seamless user experience. By utilizing this test, we create a robust validation for our login function that helps maintain overall application quality. Now let's see how we can implement a test for adding an item to the shopping cart using Cypress. This test begins by navigating to the products page to ensure the correct context for our actions. The first user action simulated is clicking on the first product item available in the list. This is a realistic simulation of how a user would interact with the application. Once the product is selected, the next step is to click the Add to Cart button, which signifies that the user wants to include this item in their cart. After the Add to Cart action, we want to verify that the cart icon reflects this change accurately, so we check that the cart count displays 1, indicating that one item has been successfully added. This assertion is crucial as it confirms both the functionality of the Add to Cart feature and the effective communication between the front end and the underlying logic of the application. By validating these steps through the test, developers can be more confident in the reliability of the shopping cart feature, ultimately contributing to higher software quality and improved user experience. Now let's take a look at a simple test case designed for user registration. This test is essential as it verifies that new users can successfully create accounts within the application. We start by using the describe function to group our related test cases under the user registration suite, creating an organized structure that enhances readability. Inside this suite, we define our specific test using the it function, which describes the expected behavior should register a new user. The test begins by navigating to the registration page using visit, simulating a user's action of accessing the form. Following this, we utilize Cypress's powerful commands to interact with the input fields. A user enters their username, email, and password. Each interaction is straightforward, thanks to Cypress's chaining syntax, which allows smooth sequential commands. Finally, we conclude the test by simulating a button click to submit the registration form. A crucial assertion follows, where we check for a visible message confirming successful registration. This step ensures that our application behaves as expected, effectively reflecting real user interactions in the browser. This foundational test sets the stage for more complex user journeys, reinforcing the importance of testing from the very start. Another disadvantage lies in potential flaky tests. Flaky tests are those that may fail intermittently due to various reasons unrelated to code changes, such as timing issues or connectivity problems. These inconsistencies can lead to frustration among development teams. For example, if a test fails because an application takes too long to load, the team might struggle to identify whether the fault lies with the code or the testing conditions. To reduce flakiness, it's essential to ensure tests are resilient and designed to tolerate minor differences in behavior. Using commands like wait, or writing more robust assertions helps mitigate these challenges. However, developers should still be vigilant about monitoring test stability over time. This requires diligent troubleshooting and consistent updates to the testing strategy. Next, we will implement a test to ensure that an item can be added to the shopping cart. This test exemplifies how we can prioritize critical functions in our application to maintain efficiency during testing cycles. In this test, we set up a scenario where a user is interacting with our e-commerce application to add a product to their cart. To clearly highlight the importance of this action, we use tags, marking this test as important. This functionality helps in selectively executing tests based on their priority. By focusing on essential tests during early integration stages, developers can speed up the feedback loop and ensure that crucial user actions are functioning correctly. The test uses Cypress's it function, which describes the expected behavior, in this case, adding an item to the cart. The test body contains the steps for visiting the products page, selecting the first product, and clicking the Add to Cart button. Finally, it checks the cart count to confirm that the item has been successfully added, ensuring both the functionality and user experience are validated seamlessly. This approach aligns with the CDD methodology, where user interactions drive the testing process. As we wrap up our exploration of CDD, it's clear that while there are noteworthy advantages such as improved user experience, rapid feedback loops, and enhanced code quality, there are also important disadvantages that teams must navigate, including initial setup investments, the potential for flaky tests, and the performance overhead associated with larger test suites. Choosing to adopt CDD should involve careful consideration of these factors, balancing the potential benefits against the challenges it may introduce. Ultimately, the decision should align with the team's goals, resources, and overall project timelines. Encouraging collaboration and open discussion about CDD's advantages and drawbacks can lead to more comprehensive strategies that support effective implementation. With a strong foundation in place, developers can leverage Cypress-Driven development to create not only reliable, high-quality web applications, but also a more agile and responsive development process overall. Thank you for joining me today as we navigated through the intricacies of the advantages and disadvantages of CDD. In today's digital world, software is everywhere, powering applications that we rely on every day. But how do we ensure that this software works just as intended? The answer lies in effective testing during development. Testing is not just a phase in the development process. It is an essential practice that drives software quality, enhances user experience, and minimizes maintenance costs. So far, we've learned about Cypress-Driven Development, CDD, focusing on its pros and cons in web application testing. We discussed how CDD emphasizes real user interactions, promotes rapid feedback loops, and helps maintain high code quality, but also acknowledged the challenges of initial setup time, flaky tests, and potential performance overhead. By weighing these factors, teams can make informed decisions on adopting CDD to enhance their development workflow. Our exploration has highlighted the importance of collaboration in implementing CDD effectively. Now, we will talk about the importance of testing in development, exploring not only why it matters, but also the various roles in a development team that contribute to this crucial aspect of software engineering. Now let's take a look at a practical example of how we can implement a user login test using the Cypress testing framework. This test is structured to ensure that users can log in with valid credentials, and it consists of a series of actions and assertions. We'll start by describing the core setup, using the describe function to define a test suite for our user login functionality. Inside this suite, we create an individual test case with the it function, which clearly states that it should log in users with valid credentials. Next, we use Cypress commands to navigate to the login page by calling visit/login. Then we proceed to simulate user input by using get to find the username and password fields and then typing the valid credentials. Following that, we instruct Cypress to click the submit button to initiate the login process. Finally, we include an assertion with URL should include dashboard to verify that the URL changes to indicate a successful login. This straightforward approach illustrates how Cypress seamlessly integrates testing into the development pipeline, ensuring that login functionalities work as expected and reinforces best practices in testing user interactions. Now let's implement a test for handling invalid login credentials using Cypress. In this scenario, we will create a test that simulates a user attempting to log in with incorrect credentials to ensure the application responds appropriately, specifically by displaying an error message. We start by grouping our test cases under the description user login error cases, which clearly indicates the purpose of our tests. Inside this group, we define a single test case with the description should show error for invalid credentials. This helps other developers understand the intention behind this particular test at a glance. Next, we visit the login page of our application with the visit command setting the stage for our actions. We then fill in the username and password fields with invalid inputs using get to select the input elements and type to simulate user input. After entering the credentials, we simulate clicking the submit button with click. Finally, we use an assertion to validate the outcome. The test expects the error message element to be visible on the page and to contain the text invalid credentials. This assertion verifies that, when users provide incorrect information, the application behaves as intended, displaying an appropriate error message. Now let's implement a test for our authentication service using Cypress, which will help validate the login functionality of our application. First, we define a test suite by using the describe function, which groups related tests together. In this case, the suite is labeled authentication service. Within this suite, we will write a specific test scenario that checks whether the login endpoint behaves as expected. Next, we utilize the it function to specify the individual test case, named should return 200 for valid login. This concise title explains the test's purpose, to ensure that when valid credentials are sent to the endpoint, the server responds properly. Inside this test case, we employ the request command to simulate an HTTP post request to the login URL, providing a body that includes the username and password. Upon receiving a response, we use the then method to handle it and perform assertions. We check that the response status equals 200, indicating a successful request, and further verify that the response body contains a property named token. This structured approach not only tests the functionality effectively, but also highlights the significance of validating backend processes in a microservices architecture. Next, we will explore how to implement a feature for user registration using Cypress, which allows us to test the expected behavior within our application effectively. The code begins with a feature declaration titled User Registration, serving as an overview of what the test will cover. We then define a specific scenario for successful registration, outlining the steps that mimic a real user's actions. First, we set the context by stating that the user is on the registration page, which establishes the starting point for our test. Following this, we specify the user's actions, entering valid credentials and clicking the register button. This simulates a typical user interaction with the application. Finally, we conclude with an assertion that checks if the user is redirected to the welcome page after a successful registration, ensuring that the expected outcome aligns with the application's functionality. By structuring the test in this way, we make it clear, readable, and maintainable, allowing developers and QA engineers to collaborate effectively. This approach not only validates the user journey, but also reinforces a culture of thorough testing within the Agile development process. Now let's take a look at a sample test suite designed to validate the essential features of an e-commerce application. The test suite begins with a top-level describe block named e-commerce application tests, which groups relevant tests together for better organization and readability. Inside, we set up a before each hook that ensures the homepage is loaded before each test executes. This is crucial because it establishes a consistent starting point for a variety of test scenarios. Next, we have an individual test case that verifies navigation to the product page. Here we use a Cypress command to select the first product link, click it, and then assert that the URL reflects the change to include product and that the product title is visible. Following that, we implement another test case focused on cart functionality. This test first simulates clicking the product link before leveraging the add to cart command, allowing us to check if the cart correctly displays the quantity of items after adding a product. Overall, this test suite not only enhances efficiency through automation, but also ensures that vital e-commerce workflows function as expected. In summary, the importance of testing and development cannot be overstated. It involves collaboration among various roles such as developers, QA engineers, architects, and business analysts, all working together to ensure a quality product. Each team member influences how tests are created and executed, contributing to a culture of quality assurance throughout the development lifecycle. As we move forward, remember that integrating tests into every aspect of development, from initial coding to final deployment, ensures that issues are caught early, software quality is upheld, and end users ultimately receive a product that meets their needs. Keep harnessing the power of automated testing, nurture collaboration among team members, and prioritize testing as a critical component of your development strategy. Together, these practices will add tremendous value not only to your software, but to your entire development process. Behavior-driven development, or BDD, is an approach to software development that fosters collaboration among developers, QA engineers, and non-technical stakeholders. It emphasizes understanding the desired behavior of an application from the user's perspective, ensuring that all team members share a clear understanding of the application's functionality. So far, we have learned about the critical role testing plays in software development, emphasizing its integration into the workflow and involvement of various team members, including developers, QA engineers, architects, and business analysts. We explored the benefits of Cypress-Driven development, highlighting its focus on real user interactions and the challenges it may present. The importance of automation and continuous integration in testing was also discussed, as well as how each role contributes to a culture of quality assurance throughout the development lifecycle. Moving forward, we'll delve deeper into enhancing testing practices and collaboration within teams to further improve software quality. Now let's implement the gherkin scenario for the successful login feature using Cypress. The first step, given I am on the login page, directs our test to navigate to the login interface of the application. This is accomplished using the visit command, which instructs Cypress to load the specified URL where the login page is hosted. Next, we move to the action phase. In the when I enter valid credentials step, we will interact with the elements on the page to input the username and password. This involves selecting the appropriate input fields using get to find them by their names, followed by the type command that simulates the user typing the credentials. Finally, the test submits the form by clicking the submit button. The concluding step, then I should be redirected to my dashboard, verifies that the login was successful. We check the current URL to ensure it contains dashboard, confirming the user has been redirected correctly. Additionally, we validate that a welcome message is visible, which further assures that the user landed on the correct page after logging in. This sequence of steps effectively tests the login functionality and provides a structured way to handle user interactions in a BDD framework. Now let's implement the first step defined in our Gherkin scenario, where we direct the user to the login page. In this code, we utilize the given function from Cucumber, which signifies the initial context. Inside the function, we use Cypress's visit command to navigate to the specified URL, in this case, the login page at login. This command effectively simulates the action of a user entering the login URL in a web browser, setting the stage for subsequent interactions within the test. Next, we will write the step to handle user credentials. Here we have the when function, which captures the action of the user entering their credentials to log in. We achieve this by utilizing the get command to select elements in the DOM. The type method is then applied to the username and password input fields, allowing us to programmatically fill these fields with specified values. Finally, we invoke the click method on the submit button, mimicking the user's action of submitting the login form. This sequence of commands not only automates the login process, but also demonstrates how Cypress enables seamless interaction with web elements. Now let's implement the functionality for verifying that the user is redirected to their dashboard after a successful login. In this code, we utilize Cypress commands to validate the outcome of the login attempt. First, we check the current URL using URL and assert that it includes the string dashboard. This assertion confirms that the application has redirected the user to the correct page upon logging in. Next, we will check for the presence of a specific welcome message element on the dashboard. By using get with the selector for the welcome message, we can ensure that this element is visible on the page. This is crucial as it provides additional confirmation that the user has successfully landed on the intended dashboard. Together, these steps create a robust test that not only checks the URL, but also verifies the presence of key elements that signify successful navigation and user experience. This comprehensive approach enhances the reliability of our application by affirming its expected behavior from the user's perspective. One of the greatest benefits of BDD is that it encourages collaboration and shared understanding among all team members from the outset of a project. By using a common language in the form of straightforward Gherkin syntax, everyone involved, including non-technical stakeholders like product owners or managers, can understand how features are intended to work. Moreover, writing tests in plain English helps teams catch misunderstandings early in the development process. This reduces back-and-forth conversations later and allows for smoother workflows. By defining acceptance criteria through BDD scenarios, we ensure that every team member agrees on what done looks like for a feature. Now let's implement additional functionality to handle unsuccessful login attempts. We will begin by defining a new scenario in Gherkin that describes the process when a user enters invalid credentials. This scenario outlines the steps we expect our application to handle, specifically that the user should see an error message when login fails. Next, we will create the step definitions to support this Gherkin scenario. We'll start by navigating to the login page as before, but this time we'll input invalid credentials, which are clearly not associated with a valid account. The syntax allows us to simulate this action using Cypress commands to locate the username and password fields, enter the erroneous inputs, and trigger the submit button. Finally, we need to validate the application's response to this action. We will check for the visibility of an error message on the page, which should indicate that the login attempt was unsuccessful. This not only confirms that our application provides meaningful feedback to users, but also ensures that it behaves gracefully under error conditions, thereby improving the overall user experience. As we delve deeper into the world of behavior-driven development, it's helpful to consider some best practices for implementing BDD successfully within your team. The first practice is to keep scenarios focused and avoid introducing too many conditions at once. A well-defined scenario should encapsulate a single piece of functionality or behavior. This clarity not only makes understanding easier, but also simplifies test maintenance down the line. Another essential practice is to ensure that scenarios are always kept in sync with the actual application functionality. This means regularly reviewing and updating scenarios to reflect changes in the application. A scenario that no longer represents the expected behavior can lead to confusion and potential regressions if not caught early. Encouraging all team members to contribute to the BDD process can yield significant benefits. Developers, testers, and product owners alike should contribute to writing and refining scenarios, as different perspectives can uncover critical insights. By involving everyone, teams can cultivate a collaborative environment where knowledge is shared and all viewpoints are valued. In summary, behavior-driven development is a powerful methodology to enhance collaboration and clarity within a software development team. By using natural language to express requirements, we ensure that everyone involved in the project has a shared understanding of the desired functionalities. Through tools like Cucumber combined with Cypress, we can effectively implement these behaviors as automated tests. Throughout this discussion, we've explored the fundamental principles of BDD, worked through code examples, and uncovered best practices for successfully incorporating BDD into your software development process. As you move forward, remember that building software is ultimately about solving real user problems, and BDD ensures that you're always aligned with those needs. Keep practicing your skills, and soon enough, you'll become proficient in leveraging BDD for your testing workflow, enhancing not just your code quality, but also your team dynamics. Happy collaboration is key in the development of software, especially when it comes to testing scenarios for product managers. Today, we're diving into how product managers can effectively engage in collaborative testing, ensuring that the entire team is aligned and moving towards a common goal. So far, we learned about behavior-driven development, BDD, and its emphasis on collaboration among developers, QA engineers, and stakeholders through the use of natural language to describe application features. We explored the Gherkin syntax for writing user stories and how it facilitates understanding across team members, regardless of their technical expertise. The integration of tools like Cucumber and Cypress was discussed, showcasing how to implement features and scenarios as automated tests. Moving forward, we will focus on best practices for maintaining clarity and synchronization between scenarios and application functionality. When we talk about collaborative testing, especially involving product managers, it's essential to recognize their unique position within the team. Product managers act as the bridge between the development team, stakeholders, and customers. They must ensure that the product meets market needs and business goals, and testing scenarios must reflect this. By actively participating in the testing process, product managers can provide valuable insights that help shape the product's direction. Now let's see how we can articulate the password reset functionality using Gherkin syntax, which emphasizes user behavior and collaborative communication. The feature begins by defining the overarching password reset capability, which signifies that this functionality is essential for users to regain access to their accounts. Under this feature, we outline a specific scenario titled Successful Password Reset. This scenario encapsulates the key actions a user takes during the process, starting with the given step, which establishes the context of the user being on the password reset page. As we progress, the when steps detail the user's actions, entering their registered email address and submitting the reset request. These steps illustrate user behavior in a straightforward manner. Finally, the then step concludes the scenario by defining the expected outcome, which is that the user should receive a password reset link in their email. This structure not only clarifies the functionality for all stakeholders involved, but also serves as a basis for collaborative testing, ensuring that everyone understands and agrees on the expected user experience. Now let's take a look at a scenario involving an unsuccessful password reset caused by an unregistered email. In this case, we define the scenario using Gherkin syntax to clarify the expected behavior when a user tries to reset their password with an email address that is not associated with any registered account. We start by establishing the context with given I am on the password reset page, which sets up the initial environment for the test. Following that, the scenario progresses with when I enter an unregistered email address, detailing the user action that triggers the password reset request. Next, we specify the action taken by the user with and I submit the reset request, indicating that the user is actively attempting to reset their password. The final part of the scenario outlines the expected outcome. Then I should see an error message indicating the email address is not registered. This clear expectation helps ensure that the application responds correctly and informs the user about the issue. By framing the scenario this way, we emphasize the importance of testing edge cases and user feedback, reinforcing the collaborative nature of product management and testing to align with user needs. Now let's take a look at how we can implement automated tests for the password reset feature using Cypress. This code begins by setting up a test suite specifically for password resets, organized with a descriptive block using describe, which helps to group related tests together. Within this suite, we have two key test cases defined using it. The first test case checks whether a registered email successfully triggers the password reset flow. In this scenario, we navigate to the password reset page, simulate user input by entering a valid email address, and then submit the form. The test asserts that a confirmation message about checking the email appears, indicating that the password reset request has been accepted. Next, we need to ensure robust error handling. The second test case simulates a user attempting to reset the password with an unregistered email address. Similar to the first case, it navigates to the password reset page and submits the request, but this time it checks for an error message confirming that the email is not registered. By covering both successful and error scenarios, this Cypress test suite enhances the overall test coverage and aligns with the expected user behavior, reinforcing the importance of collaborative testing as discussed in our context. Now let's shift our focus to tracking the results of collaborative testing. After executing tests, it's essential to analyze the outcomes together. This phase serves as an opportunity for reflection and improvement. Product managers should lead the session by reviewing test results, discussing failed tests, and identifying if there are gaps in the current scenarios. When a test fails unexpectedly, instead of placing blame, the team should investigate together to understand the underlying cause. Is the test failing due to a misunderstanding of the requirements? Is there a bug that needs addressing? Should the scenario itself be reevaluated? These discussions will drive continuous improvement within the team and optimize collaboration. As an example, if our password reset test fails due to the backend service being down, the conversation might then revolve around improving our error handling and displaying appropriate messages to the user. This collaborative troubleshooting not only aids in resolving immediate issues, but can lead to enhancements in the overall testing process. Now let's take a look at how we can implement a gherkin scenario for notifying users via SMS after a password reset request. This scenario outlines the steps that a user must follow and the expected outcome when interacting with the password reset feature. We begin with the given statement, which sets the context by confirming that the user is on the password reset page, essential for establishing the initial state before any actions are taken. Next, the when clause describes the action of entering a registered email address and submitting the reset request. This part emphasizes the interaction that the user will perform within the application. Finally, the then statement specifies the expected outcome. The user should receive an SMS notification containing reset instructions. By laying out the scenario in this structured format, it becomes easier for developers, testers, and stakeholders to understand the feature being tested and to ensure that it meets user expectations. This collaboration facilitates better alignment among team members as they engage in discussions about implementation, potential edge cases, and acceptance criteria, ultimately enhancing the product's functionality. Now let's take a look at how we can report the results of our Cypress tests in a structured way. In this instance, we utilize a Cypress task called Report Results that can automate the logging of our test outcomes. This task is executed after all tests in a spec have run, thanks to the after hook, which is critical for capturing the final status of our test suite. Within this task, we specify relevant details about the test, such as the feature being tested, in this case, password reset. This context is important because it enables product managers and team members to quickly identify which functionality the results pertain to. We determine whether the tests have passed or failed by using expressions that check the test names against predefined expectations. For example, we check if the name of the test includes specific keywords like successfully resets for successful outcomes and handles the error for failures. By consolidating this information into a centralized report, product managers gain valuable insights into test performances, allowing for informed decision-making related to project priorities and risk management. This integration of testing results with team tools facilitates transparency, making it easier for stakeholders to track progress and status updates effectively. Lastly, collaboration isn't just about tools and processes, it's about fostering a culture of teamwork and open communication. Encouraging team members to share insights and celebrate successes fosters an environment where everyone feels valued. Regular retrospectives can serve as a platform for the team to reflect on both process improvements and accomplishments, reinforcing the team's commitment to quality. As a product manager, being actively involved in these discussions, maintaining transparency, and recognizing individual contributions can dramatically enhance team morale and drive better collaboration overall. Collaboration becomes not just a phase in development, but a continuous thread woven throughout the entire life cycle. In conclusion, effective collaborative testing scenarios for product managers focus on active participation, open communication, and a shared vision of success. By embracing tools that track progress, encourage team input, and analyze results together, product managers can ensure that the product meets both business and customer expectations. Remember, it's all about collective success. As you engage in collaborative testing, embrace the excitement of working together and always aim higher. In this final section, we will do a project challenge to apply what we have learned so far. Your task is to create a continuous integration and continuous deployment (CI/CD) pipeline using Cypress for testing a simple web application, specifically a login form that validates user input. You'll need to develop this application with essential features, including username and password fields, and implement validation rules to ensure these fields are not empty, displaying appropriate error messages as needed. You'll set up a GitHub repository for this project and configure a CI/CD pipeline using GitHub Actions, which will automatically run tests whenever you push to the main branch. This will include installing dependencies, running a linter, executing your Cypress tests, and deploying the application if all tests pass. You'll write comprehensive end-to-end tests to confirm the application behaves correctly under various conditions. The complete project, including the source code and documentation, is available in the GitHub repository linked in the description, and we encourage you to leverage all the skills you've acquired throughout the course to complete this challenge successfully.